हेलो। उसमें आ रही है अब आवाज? लाइव स्ट्रीमिंग में आवाज नहीं आ रही?
कौन सी लाइव स्ट्रीमिंग?
वो लाइव स्ट्रीमिंग भी कर।
यूट्यूब मना किया था, मना किया था।
अबे बाकी
लिंक भेज दिए थे,
किसका?
उनको लिंक भेज दिए थे।
हमें जो बोला गया हमने कर दिया। अब हो रही है।
तुम इधर कोई एक दिन बाद जाना सिर्फ लॉगिन करने के लिए वो तो लैपटॉप पे लॉगिन कर देना उसी की आजी पे और लैपटॉप है हमारे पास यहाँ पे मेरे पास ऑन करना और तुम्हें की
अभी भी नहीं आ रही क्या आवाज?
यूट्यूब पे किसने ज्वाइन कर रखा है? किसने किया?
पता नहीं। हेलो। Council chapter of which IIT Indore branch chapter is the first in MP section region. Presently, there are 1200 plus IIT members in MP section, out of which
इतना ही तेज बोलिए।
100 plus are from IIT Indore and 20 plus are associated with Census Council chapter IIT Indore.
अरे नहीं मैम, आप बोलते सही हो।
The Census Council's student branch chapter IIT Indore was formed on May 30, 2022 with me and its founding chair.
सेफ टाइटल में लिख के रखा
वर्ड्स का पता नहीं लग रहा है ना।
We welcome and thank you, Chief Guest Professor Shakshi Dahandekar, Chair IEEE. Also, I would like to thank.
कोई नहीं बोलने दे रहा A very good morning to one and all present here. I'm Jyoti लिख लूंगी sorry हाँ मैं मीनू लिख लूंगी I'm Meenu on behalf of IEEE Censor Council Student Branch Chapter IIT Indore team welcome you all in today's event empowering women in sensitive मैं बोल देती हूँ छोड़ दो देख लेती हूँ ये मैं तुम्हें वेलकम कर दूंगी ठीक है
So just wait for I think 10, 15 minutes more. Okay. Meanwhile, I will be sharing this attendance sheet with you all. So just mark your name, institute name, email ID, and sign it. I will. If you have pens, or I should share with you. Okay. Okay. I will share. Let me check. Okay. Yeah, fine.
सारी है
Hello, mic testing.
अरे ये पूरा देख लिया ना हाँ हाँ लाइट
A very good morning to one and all present here. I'm Meenu Sharma on behalf of IEEE Sensor Council Student Branch Chapter IT Indore team. Welcome you all in today's event, Empowering Women in Sensor Technology, in association with the Women in Sensors. Today, we all gathered here to introduce empowering women in sensor technology. So I welcome you all to appreciate women in sensor technology. Before start of the session, let's honor the woman by saying, a woman is a full circle. Within her is the power to create, nurture, and transform. To start with the event, I would like to invite Dr. Sanjeev Singh, Associate Dean of Student Affairs, IIT Indore, to inaugurate and address the session by his motivating words. Please welcome, sir, to the dashboard.
Okay, so a very good morning to everyone. So, on behalf of Student Affairs IT Indore, I welcome to all of you in this conference, Empowering Women in Science Sensor Technology, EWST 2022. And so, Chief Guest Professor Sakshi Denkar, Entrepreneur Miss Suyasi Divedi, Miss Sheetal Singh, Eminent Speaker Professor Sudeshnath Chattopadhyay, Dr. Nitya Tiwari, Professor Shivani Mathur, and all participants present offline and online. It is a matter of privilege and honor for me to welcome all of you at IIT Indore in this event. So women in India face several challenges in moving up the academic and administrative ladder due to systemic barrier and structural factor. Gender equality in scientific laboratory and institution of higher education is not only about number, but also about various micro and macro level factors operating at institution level. Currently, there are a lot of schemes by Government of India to promote women in science and technology. One can see various schemes by Department of
Thank you so much, sir, for your kind words. For today's session, we have our chief guest, Professor Sakshi Dhanekar, Chair, IEEE Sensor Council, Vice Committee from IIT Jodhpur. But because of some personal issues, she may join us later. Moving ahead, I would like to call Mr. Pawan Kumar, Chair of IEEE Sensor Council Branch Chapter, IIT Indore. Sir, please introduce the session by your kind words. Please, sir.
Good morning, everyone. We welcome and thank you our chief guest, Professor Sakshi Dhanekar, Chair IEEE Women in Censure, and other eminent speaker of today's event, Professor Sudeshnath Chattopadhyay, Professor Nitya Tiwari, Professor Mathur, Dr. Kajal, Dr. Rani, Dr. Parik, Dr. Thakur, Ms. Divedi, Ms. Sheetal, and Ms. Suchita for sharing their experience to develop technology, startup, and how to carry research toward the industry application in empowering women in sensor technology. IEEE organization works on promoting technological innovation and excellence for the benefit of humanity. IEEE and its members inspire a global community through highly cited publications, conferences, technology, standards, and professional and educational activities. There are several societies, counseling and chapters dealing with individual research, domain in electronics and innovations. The IEEE Sensor Council is one of 7 technical councils of the IEEE and is focused on the sensors, transducers, and integrated sensor and actuators. In India, there are 30 plus IEEE Sensor Council chapter, of which IIT Indore branch chapter is the first in Madhya Pradesh section region. Presently, there are 1200 plus IEEE member in Madhya Pradesh section, out of which 100 plus are from IIT Indore and 20 plus are associated with Sensor Council chapter IIT Indore. The Sensor Council Student Branch Chapter IIT Indore was formed on May 30, 2022 with me and as its founding chair, Professor Sehwal Mukherjee as an advisor and Professor Saptrishi Ghosh as an counselor. The members of IEEE Sensor Council Student Branch Chapter are trying to create an interactive platform for young professionals like academicians, scientists, technologists, and engineers to discuss, explore, and collaborate in the domain of semiconductor, nanoelectronics, photonics, optoelectronics, biomedical, and MEMS and NAMS-based sensors. The focus of 2022 IEEE Women in Sensor is on empowering women in sensor technology. It will provide a veritable platform to nurture the young minds toward research, innovation, and entrepreneurship. Women in Sensor aims to provide globally the presence and advancement of persons who identify as a woman in the technical area and professions related to sensor. It is targeted at professional women in sensing technology from industry or academia and will provide the opportunity to create communities to facilitate knowledge sharing, provide support through highly interactive sessions designed to foster discussion and collaboration. I once again congratulate Ms. Ruchi, Ms. Jyoti, Ms. Megha, Ms. Shruti, Ms. Meenu, and other students of IEEE Sensor Council for taking up an initiative to represent IIT Indore in such a vibrant IEEE platform. And also humbly thankful to all the professors and their teams for running various IEEE chapters and branches and organize such kind of events which contribute to the vision of IITs in India. Thank you all for joining us and all the best.
Thank you, Mr. Pawan Kumar, for addressing the session. In continuation with the event, let's start the lecture series of today's event. Starting with lecture first, I would like to invite Professor Sudeshna Chattopadhyay, Department of Electrical Engineering, IIT Indore. The topic of our talk is Sensor for Biomedical Application, a dual stimuli responsive hydrogel. Before her talk, I would like to give a brief introduction about her. Professor Sudeshna Chattopadhyay has completed her BSc and MSc in Physics from University of Calcutta, Kolkata, India. She has received PhD from Saha Institute of Nuclear Physics. Before joining IIT Indore, she worked at Department of Physics, Northwestern University, USA, as a postdoctoral researcher, at Argonne National Laboratory, USA, as guest researcher from 2010 to 2012, at the Department of Material Science and Engineering, Northwestern University, USA, as a research associate, and at the Center for Electrical Engineering Storage, Energy Frontier Research Centers, USA, as a postdoctoral researcher. She joined IIT Indore as assistant professor in June 2012. She was also associated with the Department of Physics, New Mexico State University, USA as an assistant professor of physics during 2015. She was a visiting professor in New Mexico State University, USA in 2015 and RWTH Aachen University, Germany in 2013. I welcome you, ma'am. Okay. So we'll wait for 5 minutes.
आगे क्या बात
Hello, good morning, everyone. So we are just waiting for our next speaker to come. Meanwhile, we just let you go through with the main organizer or the main the chapter that we have all called you over here. So this is actually the IEEE chapter that is based upon the censor councils itself. So IEEE has multiple lining. Maybe you must be aware about IEEE, or this is basically the Institute of Electrical and Electronics Engineers. Okay, so it has been founded over in US, but over the years, over the course of years, it has been basically diversified, and many councils such as nanotechnology councils, electron devices, basically the application or specific focus based organizations has come up. So out of that, there was one council which is specifically looking towards the innovations as well as the improvements for the sensors and technology, and that is the IEEE Sensors Council. So out of that sensor council, this chapter that we have called today is one of the chapters from that particular councils, and the main agenda behind creating this council over here at IIT Indore is to basically make up forum for all such electrical or electronics as well as computer science and engineering students to come together and make this as a discussion forum. We basically every month we used to organize, we definitely organizes 1 to 2 expert talks from various industry professionals as well as from the academia background. So what is our main idea or main agenda behind creating this particular event is to make you aware, because even in your engineering field, I think most of you are from second year or third year students, because fourth years are already engaged with their placements and everything, so they don't used to get time and look towards the other things. So we basically called you over here to basically interact with the experts from various fields that are actually working in the sensors and technologies. And even our government is also focusing on manufacturing. PLI schemes you all aware of. There are product linked schemes and various even government giving funding to various startups. And I must be aware that everyone or some of you would be very much enthusiastic about creating some startup, or at least starting your career with some startups. So this forum basically gives you an idea how to look towards the industry, what actually industry want. Because okay, I am sure that your teachers, your faculties must have taught you well in your academias, so you must be very strong, you must be aware what is going on the academia side. But still in India it has been found that there is a quite a lag between what academia is doing and what actually industries want. Okay, so that is what we are bridging, that particular gap over here. And we are calling in today's session, even in today's complete sessions, you will be seeing many faculties, many industry experts coming. Some are coming online because you must be aware that there are situations that they cannot personally come over here, so they will be coming through a hybrid mode, and some will be present here in the personal. So let us welcome our next speaker, and thank you everyone for joining with us. Please start with the introduction of ma'am.
Let's start the lecture series of today's event. Starting with the first lecture, I would like to invite Professor Sudeshna Chattopadhyay, Department of Electrical Engineering, IT Indore. The topic of our talk is Sensor for Biomedical Application, a dual stimuli responsive hydrogel. Before her talk, I would like to give brief introduction about her. Professor Sudeshna Chattopadhyay has completed her BSc and MSc in Physics from University of Calcutta, Kolkata, India. She has received PhD from Saha Institute of Nuclear Physics. Before joining IT Indore, she worked at Department of Physics, Northwestern University, USA, as a postdoctoral researcher at Argonne National Laboratory, USA, as guest researcher from 2010 to 2012 at the Department of Material Science and Engineering, Northwestern University, USA as a research associate and at Center for Electrical Engineering Storage, Energy Frontier Research Center, USA as a postdoctoral researcher. She joined IIT Indore as an assistant professor in June 2012. She was associate with Department of Physics, New Mexico State University, USA as assistant professor of physics during 2015. She was a visiting professor in New Mexico State University, USA in 2015 and RWTH Aachen University, Germany in 2013. I welcome you, ma'am.
Good morning, everybody. So first of all, I want to thanks to the organizer, Professor Shaibal and his group, Jyoti, who has contacted me for this and for the presentation in this platform for the empowerment of the women. So I am just really glad. Yeah, that would be great. Yes, but is it working? Otherwise, it is fine.
Yes.
इसको लेना कैसे है? हाँ? वो ठीक है, तो माउथ पीस में ही बोल देती हूँ, ये प्रॉब्लम है ये माउथ पीस में बोल. So today for the EWST 2022 for this presentation, and then I am just presenting on the topic for sensor for biomedical applications. We can talk about that biosensors, but I just put it in specifically because it can be used for other purpose also. And so the main material which is used here, the dual stimuli responsive hydrogen. So I would explain all the points during my presentation. So, but this presentation is not only the scientific presentation, right? So I am supposed to tell about the journey of a woman. So it would be not for the woman also, of course, this is true for, men and women because we are working together, right? So in that case, first few slides, I will talk about the journey towards the science and engineering. So it would be kind of nowadays, it is kind of interdisciplinary. There is no specific partition between these two, right? So I'll just already, I think she has already mentioned about the my work before here. So I'm just wanted to briefly tell why, because to connect it, so you all can do it for that only. So it is like that. Before I joined here as assistant professor 2012, prior to that I was in Northwestern University as postdoctoral fellow and research associate and other, already with Argonne National Lab for the visiting professor, visiting researcher, and then also after joining here, I was visiting professor at RWTH Aachen and also in New Mexico State University, USA. And before that, I did PhD from Shah Institute of Nuclear Physics and MSc, BSc from Calcutta University. Okay, so this is just only to mention that we all can do it. So for my case, I was just doing everything like that. Many of the women don't feel that there is any restriction or kind of barrier because of other things. It would be there. But if you have the willpower, you should be able to do it. So all are doing everything. There is nothing that, okay, if you do the research, if you do the engineering, some technology related work, that means you will not be able to proceed on your family and other things. Actually, you should take it as a positive way. It is a huge support for men and women. So it is vice versa. So maybe I'll give some time to the students to come. Yeah, that would be easy. Okay, so can you continue? So maybe or 2 minutes. Okay, so next, so why science and engineering? Of course, we have our choice, which direction we want to go. There is no kind of burden like that on us. There should not be that, okay, I have to go like that way. But for science and engineering, since there is a platform for science and engineering, I'd say, so in that case, so there must be some excitement of that. That means after doing something, you can you can feel some excitement. That is possible because you can do different job, of course, but doing something, exploring something, if it is honest work, you feel that if it is small work even, you feel excited about it. Okay, then there should be some, you can feel that when you are working, some eureka moment like that. That means, okay, that changes my direction, everything. Okay, so through your pathway, you should, feel these points, and it will be your kind of it will make you to do more work towards this direction, because some happiness should be there. Otherwise, we cannot do anything for only the job and money. Of course, we have to do, that is one thing. But additionally, we can get such kind of things, and we can spread these things to others also. So inspiring part. So I am trying to inspire you so that you can get as if when you are doing this work as a PhD student, as a, engineering students, BTech, MTech. So all this, because when you are doing science, you can explain the things, you can explain new things to others. Okay. So what is the up-to-date status of any kind of field? So your satisfaction, of course, with that, and happiness, the final things. Otherwise, none of the work will be kind of successful, of course, right? Successful means it is the relative term, so that the successful in terms of your kind of mental food or like that way. So just briefly, since I have few moment extra, that's what. So just PhD already mentioned that I did that optical spectroscopy and structure of polystyrene film in gold polystyrene and composite. I just wanted to mention this, the title of the talk, because I did full science during that time, not the real application. But this helped me in a surface physics division, how surface can be changed. Mostly it was the science related work. Okay, during my PhD. After that, during my postdoc, so using this science, again again the surface science engineering related. So first I just, in the physics department and also after that material science and engineering department. So how can I utilize this work with the application oriented? So energy frontier research, as I have told, I was associated to develop the energy storage materials. So that without that science, it is, of course, whoever is doing engineering, same, you are learning the science some way or other, okay? So that we can translate to the engineering, so that it'll be always fruitful. And then now at IIT Indore, if I just overall brief, I can say that I'm working on some different, again, as I have connected the surface interface related materials. So how can I modify the surface and interface of the material? Because we are not chemists, so we may not be able to develop a new material, okay? In that respect, our approach is that how can I coating and engineering the material, not only coating, just low dimension material. So how it can change the property of a existing system. So that is the approach, and then their application in different direction. So energy storage, as I have told, I'm just doing, and also for the photocatalytic activity and nanotechnology in biomedical application and environmental remediation. Other things are there, soft matter physics. If you see deeply that these are connected, all this, because the characterization techniques, whatever we are using here, X-ray scattering, atomic layer deposition in depth, and in addition, there are many other techniques which is required to understand the system. So that is the approach. So now today I will be focused on more here because the talk is on the sensor, right? So biosensor or sensor for the biomedical application. So this part. So that is, I'm not just giving, this is the kind of work and like that we did, and the main, as I have told, design of low dimensional material, our targeted problem towards our energy research, nanoscale device in the field of flexible electronics, photonics, optics, medical diagnostics, and environmental remediation. So magnetic nanoparticle, embedded hydrogen. So this part I will focus today. So it is not changing. Can you change the next slide? Yeah. So now the right thing. So since today's scientific talk for sensor for biomedical applications. So dual stimuli responsive, pH sensitive, and superparamagnetic hydrogel. So here dual stimuli responsive. So I will discuss each point so that you can understand what I want to say. So here three things are important. One is hydrogel, of course I will discuss, and dual stimuli responsive. So here this is pH sensitive as well as it is magnetic field sensitive, because it is superparamagnetic nature is there as well. So this is a promising platform for biomedical applications. So now, sorry. Here. Okay, so here if you see the briefly, just or crudely, I would say that hydrogels, you can see them in more details for the book, you can read for that. But hydrogel is nothing but a 3D network of polymeric chains that are cross-linked by chemical and physical bonding. Because if you see that polymer, maybe you are aware of some, kind of briefly you can just think about, because one molecule, two molecules, and like that, for number of molecules, if they are connected with each other, so this is kind of longer chain like that way. This is the little bit higher molecular weight, because many molecules are attached, or many atoms are attached in that. So this is the polymers. Now if we think about some polymers are cross-linked and make some network, 3D network, then it will behave like a gel or hydrogel, if it because hydro means it absorb water. Okay, so gel first thing and then hydrogel. So okay, so this is the thing. So it absorb and retain significant amount of water. That's why hydro word is coming. And this is, of course, it should be created by hydrophilic group. Otherwise, it would not, absorb water. Okay, so this is the. Now, so here many properties are there, chemical and physical properties. So I have just, focused on the chemical properties, which is kind of permanent because it would not detach. Okay, so this is a covalently cross-linked network, which is the permanent solution up like that. So it is just an example for same hydrogel based on the how much it can take water. So it is the dry hydrogel when you have formed. Then after absorbing the water, you can see that it is the volume will be much, larger with respect to the pristine polymer or pristine hydrogel. Okay, so that is an example for that. Oops. Sorry. Yeah. So here, next point, so hydrogel point I have discussed. Now the stimuli responsive. So there are many kind of different stimulus. That means how you can make it work. Okay, so that is the, so it can change, this hydrogel can change its water absorbent property in different environment. Okay, based on that, we can tell that, okay, this is magnetic field stimulation, or it is pH stimulation, like that way, pH related stimulation, or like that way. So if you divide that, so physical stimuli within that, light can be one of the stimulant, pressure, temperature, electric field, magnetic field. So many possible probes are there to stimulate this kind of hydrogel to change their behavior. Okay, so that you can, that hydrogel can be used to detect any changes in a for the diagnosis purpose, or like that way. Okay, so then enzyme, antigen, DNA can change here, ionic strength, pH, CO2, glucose, that kind of stimulate. But it is not that it is of course available, and not that whatever I want I can make it. Okay, so for this purpose we have to design in planned way what you want to do. So our objective was that how can we change the pH sensitivity, because this hydrogel, I show that it is a biocompatible, because whenever I am talking about biomedical applications, so it must be biocompatible. Otherwise, if I put it in our body, then it itself behaves in, it is toxic, then we will be in trouble, right? So biocompatibility test or toxicity test is important. Then we want that it should be pH sensitive, because within our body, many diseases, for you will see the pH will be changed. Say pH normal condition, water pH is 7.4 or so. Okay, just ideally 7, but it is, you can see that 7.4 or so. And then when we'll put it in some different, I'll show that here's some application. I think I have put it. Oh, no, sorry, I am discussing that point. Okay. So that if we put it in a body, so if you had some cancer cell, so it will reduce, may 6.1 to 6.5 and like that. So if your hydrogel is pH sensitive, then it can detect, okay, and it is low cost also. Okay, so second one is the, say some skin disease or like that, you will see that it will reduce 4 to 6 based on the which kind of skin disease are there. Now next, say some kind of GERD disease, which is related to the kind of stomach. There is a some effluent which is kind of it can make you it can change. If you have that GERD disease, it will change from 7.4 to 4.1. So it is a very clear change. If you can probe it, then you can get that indication, yes, you have the GERD disease. So it doesn't mean that already the sensor is not there. It is there, but it is costly, and you need to buy it or kind of import it from abroad. Like GERD disease, I am giving you an example. It is antimony, so it is also toxic. Of course, we are using very small amount, but it is toxic, and it is expensive, and it would take time to bring it from abroad and like that way. So that way, such kind, I will show that how this hydrogel can be useful for this kind of sensing purpose. So here hydrogel has some examples, pH sensitivity, so did various application in the field of sensing actuators. So as I told, it can be applied for different biomedical applications as well. So it is already used for not this hydrogel, different hydrogel in contact lens, drug delivery system, tissue engineering, agriculture, like that. Okay. So now Of course, when I am talking about sensor, so all of you kind of know that who are working in the sensor field or who has the common idea that of course it should be low cost. It should be very sensitive. Otherwise, if you take more time to sense the changes, then it is difficult to understand that you cannot put the, at least for the biomedical application, you have to put the material inside your body. You cannot keep for a longer time. Okay, so the sensitivity should be high. It should show repeatability. That means it's not that one time it would work, because then the changes is difficult because you cannot, calibrate it properly. Reliable, of course, the reproducibility, it should be high resolution so that, if you change pH 4.1 to 5.1, it will show the changes. It is not that it will, for a longer range, it is so constant. So resolution must be good. And fast response time, already we have discussed. Okay. Here, so as I was saying, for the different disease things, so of course I was thinking that I have not put that here. So this is the GARD disease, kind of one of the example I was saying, that if just whatever this is the here, so this will change when you have the disease. Instead of 7.4, it will be 4.1 sharply, okay? And for this kind of, for tumor, if you have, so then it will be with respect to 7.4, pH will be 5, like that. So that's what we can use it for different sensing purpose or diagnosis purpose, okay? Fine. So now I am coming to the point, the hydrogel, whatever we have found. So initially, so I need, as I have told, I need the pH sensitivity and magnetic property. Why? Because I want to use it for the pH sensing, and then I want to use it so that for the, I can separate it out by the magnetic field from the outside. I can control the system. Say, for an example, I'm giving very crude picture that if your material is inside your body, so you can control your material from outside with the magnetic field, because it will go through the different direction, so like that way, okay? So like, and also not only magnetic field we can control, so you can also collect the information from this magnetic field. I'll show the schematic afterwards about that, okay? So here the hydrogel, as I have shown, and the different pH, if you see that morphology here, so it is different ratio you have prepared to get it the optimum solution for two different monomer of the polymer. As I have told, polymer will make the chain, cross-linked chain, and it will make a 3D network of the system. So that is, so these two different polymers we have used which are also pH sensitive, the functional group. And then if you see that morphology, it is pH 9, pH 7, so it is close to each other. But pH 1.4, you can see that it is changed a lot, because, so that's why this sensor, this material is, because every material cannot be, cannot work for whole range, pH 12 to pH 1.4, okay? So, but this sensor must be very good, pH 7 to 1.4, because in between picture, if you see, there is a huge change. Afterwards, I have the, because this is the normal hydrogel, and then I'll talk about the magnetic hydrogel. You can see the changes in the morphology, but here changes are less. So above pH 7, it doesn't show much change, but our objective is to find out the changes in pH 7 to lower, because most of the disease goes in this direction, okay? So now the formation and with the magnetic hydrogel and checking that, yes, magnetic nanoparticles, so Fe3O4 we have used, which is kind of non-toxic, and already biocompatibility will show toxicity test, and then we can see different ratio. I have shown 3, but we have made different, and we have chosen the optimum ratio. So now biocompatibility, you can see after 72 hours, even the cell culture like that. It is nothing but if you, because we are engineering and physics and different aspects. So you can see the your material is fine because your cells, are alive after 72 hours. It is a kidney cell we have used, HK293, and it is alive after 72 hours also in presence of this material. So we don't need to keep the material more than, even 10 hours or like that. So 10 or 20 hours maximum, but 72 hours that we have just checked that. And okay, fine. Then the property pH sensitivity. So we can see that the pH sensitivity here to here, how it is changing. So if it is 100 gram per gram or it is around 10. So in this range, it is working very well. And that we have shown the bar diagram, and this is the real picture. And the same hydrogel at pH 7 and pH 1.4, you can see the swelling property of pH 7, how it is changing the volume. You understand that with it, there is a magnetic nanoparticle, Fe3O4, around size 10 nanometer. So if it is squeezed, all the particles will be kind of congested, and if it is expanded, it will be dispersed. Okay. And also the volume change, from the volume changes, we can see the different impedance also, if you see the properties, okay? Because, and then magnetic properties also has been checked that, okay, it is working properly, okay? Magnetic properties there. And then we have checked the switching, switch on that. I have told the second property, we need to get it back, right? So I'll go up and down. So switching property, which is pH 7, it will be like that. And if we make it 4.1, then it is going down, and then it is reproducible. Okay, so again and again, switch on, switch off factor we check. And so it says that dual stimuli responsive, pH sensitive, and superparamagnetic hydrogel has been prepared and provide, which may provide to utilize the system efficiently in diagnosis and sensing purpose. So this indicates the excellent response to the pH, that reproducibility is there, the hydrogel itself is low cost, and then this can show the good pH sensitivity within that range. So here the magnetic nanoparticle, as I have shown, you can see the pH 7 morphology, pH 5 and pH 4.1 and pH 1, how morphology is changing. And along with that, EDX, the energy dispersive X-ray, and there you can see the how Fa elemental mapping is there, how iron nanoparticle is getting dispersed within the system, and then it is very dilute. It is very dilute, and then it is getting congested in pH 1.4. So what was our purpose? Because if you see these changes, then we can say that, okay, it can change its susceptibility and impedance. Okay, so that because magnetic nanoparticles, when it is well dispersed, its susceptibility will be different than the when it will be congested, that means very congested, okay, situated. So sorry, something is there. Can you close that annotation? Decline or something? Sorry. Yeah. So using this is the schematic. So it is the magnetic handheld probe. Okay, this probe is already available in the literature, and people have, because instead of squid, earlier people used to investigate things with the squid. It is very expensive equipment, but nowadays people are for such kind of investigation, because this is our system, and this is the handheld kind of probe which have the permanent magnet which can produce the magnetic field, and the induced magnetization can reach to this magnetic sensor, and it can sense, and you can detect that the changes between two pH. So you can check the comparison. Okay, so that is a schematic for the how can you use this hydrogel for sensing purpose. Okay, so directly you can achieve this. So for the another is that, as I have told, through magnetic probe, because the induced magnetization will be different because of the when it is well dispersed, the magnetic nanoparticle, when it will be congested, and also the because of the volume change, impedance also will be different if your separation, if we put this kind of system in this manner. So we have designed that way, and you can see that when it will be swelled. So this is the magnetic field line. So hydrogel is there. You have the magnetic strip here, magnetic probe here. So field is there. When it will be swelled, it will be closer to this and you can see. So it is a schematic for such kind of system to be used. So that also we have checked in our lab whether it is really our resolution is okay this with this sensor, that whether these changes can be detectable or not, because changes are there. We are telling okay that much 95% this is increment in this, but whether the small changes, as I have told, resolution should be high, otherwise we cannot detect the changes, right, with the available equipment. So that we check that it is within the detection level, and you can see very clearly is a kind of even a rough system. You can see very well that how it is changing with the enhancement. So put like that way. So this is the potential application for, of course, the sensor diagnosis, disease diagnosis, even magnetical targeted therapy. We can use it because if it is inside the material, so we can make changes through the probe with the external magnetic field, and we can proceed. So I would first acknowledge our group members here and the collaborators in different institutes, because many collaborators are in the same institutes. I have just put their university name and all the funding agencies, because without that we can't proceed. And of course, without my family members' supports, we can't do it. Okay, so because this is a great support, because for all of you, that's what I had started. That is not that you will be restricted for your work. Take it positively for men and women. So it is a vice versa support. Okay, so if you get that, then you can do more. Okay, so that's what just I put this slide for today's presentation. So think about, so don't make your constant, oh, this can be, so many things can happen and everybody is, dealing with that. So so I should acknowledge without them, also if you have willpower also, but we need the support, otherwise we can't proceed. So now I acknowledge all the wonderful and strong women. So you make the world such a better place to live in. So thanks to all of you for this today. Okay, so and this, the choice is up to you, which field you want to go. So there are many choices. Yeah.
Thank you, ma'am, for wonderful presentation. Now the session is open for question answer, and you may feel free to ask questions from us.
Yep.
You have explained the hydrogel.
Yeah.
While testing the hydrogel for various diseases, do we need to put that hydrogel inside our body, or we can check that methodology by outside, by probing?
It is actually based on your disease. If it is a skin disease, say, you want to detect, I'm saying that for sensor purpose, so then you can put it outside the body. But when it is for the internal something, as I have told, guard disease or like that, you need to put your hydrogel there so that it will be in presence of this, body liquid, which will change its pH. Okay, so otherwise you have to extract that material, that liquid, and you have to put it on the hydrogel. But generally people used to do, because you need very small, and already the technique is available for different material, like as I have told, antimony, for an example, for guard disease. So they used to put through, like your mouth and like that. Is of course, doctors have made it comfortable at this point, but you have to put it there, and it will to see that for 20 hours you have to monitor how it is changing. Okay, because it is not continuous, it is whenever the flux will come, then it will detect. Okay, so 20 hours they will monitor, and then they will tell, okay, this is the, because that means maybe 50% of time it is in 4.1 pH. That means you have that disease. Or if it is a not complete disease, but it is you can sense that it is going towards that direction. So then not for the 50% of time, maybe 10% of time is 4.1. So you can also probe that what level your disease is. So in that case, you have to put the hydrogel also, of course, not the directly, maybe within the capsule. So that part we cannot tell. So the science and like that can be done, we can. So maybe commercial level we can do that kind of work. Okay, so with some capsulate, because many things capsulated part with some holes, you can put it. So liquid will go inside with the holes and like that, not directly putting like that way. Okay. Yeah, it can be used in other fields. As I have shown, it's already been used in agriculture. Of course, diet delivery is a part of the biomedical field. So I just, just wanted to tell you. So there are contact lens. So some kind of commercial, some applications I have shown. Oh, sorry. Oh. Sorry, just give me a moment. Maybe my lap, this here. So it is, if you see in agriculture, tissue engineering, disposable diaper, in fact, diaper, huge use is there, because you know that for the kind of absorption and without, making any harm to the baby's body or old persons and aged person and like that way. So this is very, already people are using for long for this, okay? And so then, of course, the other things are there. So many part I have shown few, but it is, yeah. Yeah, this hydrogel is particularly for pH sensitive and magnetic field sensitive. But as I have shown in the another slide, I think here, or some stimuli just before, yeah, here. So, but yet it can be the electric field, light changing, pressure changing. So that kind of thing, but that for that you need the different hydrogel, because one hydrogel may not be sensitive to every stimulus. But because we need to design material so that it can interact with, or it can show its, kind of changes because of this probe, the pressure and like that. So that kind of composition should be there in that case. Or maybe for light, it should be photosensitive in that case. Okay, so that is a various application, yeah.
Any other question?
Yeah, please. Yeah. No, we didn't. No, we didn't try it. We have tried for the human cell, that is biocompatibility kind of thing. So not for the direct disease detection, but to check the biocompatibility. That on the human cell, we have kept it for 72 hours to check that whether the cells are live or any changes are there. So it was healthy cells we have got after 72 hours. So that part we have done, but not directly the animal housing and like that. So that part needs to be done for the real protocol. Yeah. Okay. Yeah, sure.
Thank you, Professor Sudeshna Chattopadhyay, for an enlightening and entertaining session. We are grateful for the time and efforts you took to share your thoughts and experience with our IEEE community. To honor Professor Sudeshna Chattopadhyay, I would like to call Ms. Ruchi Singh to felicitate her with a memento. Ma'am, please. Yeah, thank you. Thank you, ma'am. Thank you, Ms. Ruchi Singh. To proceed the lecture series, I would like to call Dr. Nitya Tiwari, DST Inspired Faculty, Department of Electrical Engineering, IIT Indore, for second lecture. She has completed her MTech at IIT Bombay in 2012 and PhD from IIT Bombay in 2019. And then she joined as a lead engineer in Samsung Research Institute, Bangalore, where she was promoted to chief engineer. Currently, she is working as a DST-inspired faculty in IIT Indore, and her research area consists of single-channel speech enhancement to improve speech quality and intelligibility, noise-aware speech enhancement, multi-channel enhancement, real-time implementation and evaluation. I welcome you, ma'am.
Am I audible? Yeah. 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 It's okay. Uh, I hope my microphone is not too noisy. Yeah, okay. Yeah. Thank you, everyone, for giving me this opportunity today to speak here. And thank you sincerely. I thank Professor Shebel for giving me the stage and platform to present. So I'll be talking on sensor technology and speech, particularly on speech signal processing. Although I am not from sensors background, but as in any other electrical engineering specialization, sensors are playing a key role in signal processing as they are acquiring the data. And particularly in my case, I used the sensors which we used for speech signal processing. Yeah. So because I am not very much into the technology domain, my talk will be more of a in a general sense, and I'll be trying to motivate the female students and girl students, not only them but males also, but more focus today is more on women. So yeah, I'll start with a brief background of from where I come. Then I'll move to what is sensor technology, how sensors are used in speech signal processing, and then how can we support women in science, technology, engineering, and mathematics. Yeah, so my background, I am Indori, that is, I am born and brought up in Indore, and I come from a family of doctors. My father is a pediatrician, my mother is a pathologist, and unlike any other Indian traditional family household where if you have a boy and girl, the boy is supposed to become a engineer and girl is supposed to become a doctor. In my family, it was the other way around. So my father motivated me to pursue engineering. Particularly, he encouraged me to do mathematics from very early on, and my mother wanted to continue the legacy, so he promoted my brother to be a doctor. He is completed MBBS and is a doctor in Devas. So I have done schooling also from Indore, from Chaitram School. And I like to sincerely thank my mathematics professor, Vinod Shukla and Dinesh Thakur, who encouraged me and removed the math anxiety from very early on. So it is very necessary that you are not anxious of doing math, and particularly girls tend to become very anxious. So they helped me solve my math anxiety, and Vinod Shukla sir helped me to gain confidence in public speaking also. That's why I'm able to stand here and talk. Yeah. So undergraduation from SGS ITS Indore in between 2006 and 2010, and I was in electronics and telecommunication department. My that time HOD was Professor Prakash Vyavare, and I sincerely thank my Professor Anurag Srivastav and Prakash Vyavare sir, because they motivated all the students to continue their education, particularly higher education, to such a level that our exams and vivas were scheduled so that they do not clash with gate examinations and subsequent interviews that were to be held at IITs. Then, how did my interest come in higher education? So that was because of my BTech project supervisor, Professor Anurag Srivastav, who had recently completed his MTech from IIT Bombay that time. And he used to talk so much about the work environment and culture at institutes, premier institutes like IIT, that I got very much interested in doing higher education. And he guided us on this project for automatic number plate recognition, which was his MTech course project topic. So I thought that if MTech course project topics are such encouraging and such exciting, I should pursue higher education, and I got interested in doing MTech. So then I pursued MTech between 2010 and 12 at IIT Bombay under supervision of Professor PC Pandey. So what happened is, every time in my home, all the discussions are related to medical field. And so what happened, I wanted to pursue engineering, but I want to solve problems which are related to medical field, because I constantly heard discussions between doctors as well as their concerns for patients, like how can engineers solve these problems. So I wanted to pursue an area in which engineering is applied to solve medical problems. So I saw that Professor Pandey had floated a project topic in which they wanted to solve the problem of hearing aids in speech signal processing area. So I requested him, and I then joined MTech project under his supervision. And I especially thank all the other research progress committee members, Preeti Rao ma'am, Professor Gadre and Professor Raj Babu, for their continuous support. Then soon after MTech, I have done PhD from Bombay, IIT Bombay, between 2012 and 19. So what was motivation for doing PhD was that there was a constant exposure to the research area from MTech itself, and I understood what were the challenges involved in the signal processing area, which I was not able to solve during my time or during my stay at MTech. So I got interested in how should the remaining problems be tackled in the area of signal processing for hearing aids. Then was the work environment and the culture at the institute. So it was very free environment, a sense of safety and security. You can work at any time and at any hour, and it encouraged me to pursue PhD. Particularly, there were women faculty members in the department like Professor Preeti Rao and Mariam Shujai Bagni, who encouraged me that I can do PhD. And then I had an academic inclination, and that I realized while doing teaching assistantship during my MTech program. So I liked interaction with students, and that I had during labs or Viva sessions. So I had an inclination, and if I want to pursue a career as a teacher, I should be doing PhD. So that was one of the motivations. Of course, my family, teachers, colleagues, and supervisor, all of them were very encouraging. And towards the end, there was a test of whether I really want to do PhD or not, and this was done by my supervisor. So when I approached him that should I convert my MTech program to PhD, so he denied. Then he asked me that I should sit for placements. Then I should get a company. I got a company, and then he said that now you decide whether you want to do PhD or go for a job and get your MTech degree. So then I completed MTech, and then again rejoined as a PhD scholar after this. Yeah. So my thesis topic during PhD was amplitude compression and noise suppression for hearing aids, again under supervision of Professor PC Pandey. Now, what happens for female students, typically when you try to do PhD at this stage is you are at a marriageable age, and the question of there is a question of marriage. When will you marry? How will you marry? So for me, I was very lucky. Soon after I joined PhD, my husband joined as a PhD scholar in the same department. In fact, in the same lab. So. So I had all the motivation, discussion, and support from my husband, Dr. Nataraj KS, and as well as his family members, because once your husband and you are facing the same situation, same challenges, same stress and atmosphere, it becomes very easy to convey to your family members, or specifically in-laws, that what challenges you are facing. So I was very lucky in that sense. So yeah, I'll come to my research area, which I pursued during MTech. So soon after joining PhD, I realized that unlike MTech, which has a very fixed duration, very defined format, PhD is not like that, and it involves a lot of ups and downs and success and failures. So you need a lot of guidance, support from supervisors, teachers, as well as family members while you are doing PhD. So one more thing which I learned only during PhD was, if you often get stuck in a loop of trying to solve a problem in a similar manner, and there is a need for change in perspective. So what happens is, if you're not discussing with your colleagues or friends which are outside your area, you will not have a newer way or perspective or a different angle to look at the problem. So, and this I'm very thankful that I got this learning during my PhD time, that interdisciplinary or inter-lab interaction is very important. So yeah, so then I saw during PhD that you can be stuck with a problem for like months and months for a long time, like a few months, even 6 months or 1 year. So it needs a lot of patience and perseverance. And I saw my seniors, particularly female colleagues, who had families as well as kids to look after too, and they were able to manage it. So it is very important for students to have role models of in similar situation around, so that they can make up a decision. I could have easily quit after 1 year of failures and not being able to achieve anything, but I saw that my colleague Mrs. Shobha Gopal Krishnan is able to manage her PhD with 2 kids. So I should be able to do it with my husband sitting inside the lab. So they especially these students inspired me. Then I was also having a lot of industrial exposure during PhD. So IITs have this benefit that your supervisors are often collaborating with many research industries and startups, and you get exposed to these startups and industries. So we were exposed to Quadio devices, which is a hearing aid development and hearing aid algorithm development industry which is in Pune. And I used to visit this company a lot, and it inspired me that not only academia is doing research, the industry is also doing equally good amount of research, and they promote and often seek help from academia. So in the end, I'll again like to thank Dr. Nataraj KS because he was the one who joined PhD after industrial experience. So he promoted me to, after PhD, to take up a role in Samsung Research Institute, Bangalore. In between 2019 to 2021, I was there as a lead engineer and later chief engineer. So how did I end up in Samsung Research Institute, although I had an academic inclination, is that I was attending many such workshops, which is being held right now. I attended conferences and student industry interactions. And I was highly inspired and motivated by Dr. Sunayana Sitaraman, who is currently Director of Research Fellow Program, Microsoft Research India. And she had given a talk concentrating on research fellowships for female students and female industry, incorporation of more female employees in industry in InterSpeech 2017. This is InterSpeech is a conference in our area. Then I had an interaction with the Samsung Bixby team who were recruiting research scholars who are about to graduate in 2018, and therefore I joined Samsung in 2019 as a automatic speech recognition front-end engineer. So here my team was involved in developing a device which is Bixby, which is very similar to Amazon Alexa or Siri, wherein there is a speaker with microphones, multiple microphones, which can take in commands from the user, recognizing their voice characteristics, suppressing the background noise, so that this becomes a smart speaker which can be then connected to many home appliances. So that was my role, and I had to develop front directly raw data which is directly being acquired by the microphone in this Bixby device. So again, here at Samsung, I was very lucky because they promoted women employees. There was gender equality in position as well as compensation. I saw many women team leaders in Samsung, so they generally felt that women are better in managing a huge team because they because they tend to tend to have a better convincing power. So they had many women team leaders, and there were special leave for women employees, of course, for maternity, childcare, and menstruation. So so after 2 years of experience at approximately 2.5 years of experience at Samsung, because I had an academic inclination, I had applied for DST Inspire Faculty Fellowship, and because of that, I have come to IIT Indore Electrical Engineering Department, and I sincerely thank all the faculty members and Electrical Engineering Department for giving me this opportunity, and to work, to teach, and to interact with students as well as do my research work. So I sincerely thank again Professor Shaival Mukherjee and the entire EWST organizing committee today for giving me this platform. So with this huge introduction to my background, I'll move to sensor technology. So sensors, as we all know, are devices that sense physical phenomena in the world around us, and then they convert them into signals that we can process or analyze. So there are different kinds of sensors. So I am very thankful to sir because of this opportunity. I studied sensors and came up with some kind of slides to present today. So there are different kinds of sensors: microfluidics, biosensors, optical sensors, and physical sensors such as temperature, mechanical, and magnetic and acoustic sensors. I was mostly using acoustic sensors. So these are some of the sensors that I could look, and I found that sensors are not only in speech signal processing, they are everywhere. So one thing which we saw during lockdown and work from home was we were constantly using the online meetings, and we were using microphones, speakers, image cameras, and all microphones and cameras. These are both sensors. So what does sensor technology involve? It involves understanding what are the sensor materials, their fabrication, design, modeling, evaluation of these sensors, and then we have sensor signal processing and sensor data processing, and I'll be mostly focusing in today's talk on sensor signal processing, particularly how do we either amplify, filter, or linearization, modulation, or demodulation of the signals which are acquired from the sensor, so that we can make decisions or control systems using this sensor data. So this is a overall block diagram of what I understand from sensor signal processing, that there is a physical phenomena which results in certain signals which are not in electrical domain or the domain which we are interested in, and then there is a sensor which senses this physical phenomena, converts into a usable form of a signal, and then we can do signal processing via a signal processing unit, which can be used as output for controlling a system. So what are the sensors that we typically use in speech signal processing? This is microphone, I am talking, so this is speech being recorded by this microphone sensor. And so I'll be focusing in today's talk more on microphone sensors. So speech signals are generally acquired by these microphone sensors, which are devices which is capable of transforming the pressure signal of sound into an electrical voltage. So the sound waves travel in a medium, they lead to vibration of the particles, and as soon as they hit the microphone membranes, it leads to vibration of the membrane of the microphone, and this can result in the usable form of a signal which can be later processed, that is electrical voltage signal. Often we use in sound processing the unit of the sound as sound pressure level because of this fact that indeed it is sensing the sound pressure and converting it into electrical voltages. So there are these different types of microphones: dynamic microphones, condenser microphones, ribbon, carbon, and crystal microphones. And since I was involved in hearing aid applications, most of the times we were focused on condenser microphones. So this is a table which is briefly comparing the 5 different types of microphones. So the dynamic microphones are the one which are having a coil of wire attached to a diaphragm, and this diaphragm moves in a magnetic field, creating a voltage in the wire, which can then be sensed. So these microphones are very durable, are high mass. Because of their high mass, they can handle actually very loud inputs. Then these are directional and they don't have very inherent noise. Then we have condenser microphones. These are consisting of electrically conductive diaphragm in proximity to metal plates, to a solid metal plates, and when this diaphragm moves because of the sound pressure, the distance between the two metal plates changes, and that results in change in capacitance, and that is why this is the condenser microphone. This has low mass and has variable polar pattern, but this has a problem of diaphragm saturation, meaning that if you apply very loud input levels, the output of such microphones often saturate. Like if I start shouting right now or start increasing my volume level right now, the microphone may saturate. Then we have ribbon microphones, which is similar to dynamic microphones. These are electrically conductive ribbon, which moves within the magnetic field with sound pressure. Again, they have low mass. They can handle louder input as compared to condenser microphones. They are directional. And one more property is that they have non-linear response, and what is the benefit of this nonlinear response is that it mimics the human perception of loudness, which is very highly nonlinear. So as at a particular frequency, if we play a sinusoidal tone and we try to feel what is the perceived loudness level of this tone, what will happen is initially the loudness will grow very quickly, perceived loudness will grow very quickly, and it will tend to saturate towards very higher input levels. So that is why this non-linear response of ribbon microphones is important. Then we have carbon microphones and crystal microphones, wherein the properties of these carbon granules or the crystal change according to the sound pressure level, and these are not very often used because of their limited frequency response in current day applications. Yeah, so I'll come to sensors in speech processing applications and what all application I had seen during my research work and what kind of microphones would be suitable for them. So initially I was involved in speech amplification because hearing aids are the devices which need to solve the problem of lack of hearing for the elderly people or even for young people who are exposed to a lot of noise. So what happens is algorithms often need to take the input level, find the approximate energy in that input level and apply amplification based on what is the input level. So if your input level is very low, you need to apply a higher gain, and as the input level increases, the gain should go on progressively reducing. And this is known as frequency dependent amplification as well as dynamic range compression. So if we want to do frequency specific amplification, the response of the microphone frequency response of the microphone should be very good, and it should not have any saturation issues for large range of input values, so that it accommodates large input dynamic range, which can be then compressed into small dynamic range of the hearing impaired users. Then there is an application for noise suppression in hearing aids or in automatic speech recognition devices or media devices. So this comes particularly useful for front-end processing in the ASR industry. Here again, we have to do frequency-dependent noise suppression because the background noise need not be present only at single frequency. There can be multiple people talking in the background, which can act as noise. And therefore, these noise suppression algorithm needs to estimate the frequency-dependent noise first and then suppress it in order to improve speech perception. So the microphones here inherently should have low noise. They should have directional properties, that is, they should be enhancing speech coming in from the direction of interest or the speaker, and should suppress the noise which is in the background. When in a noise suppression scenario, people use a secondary microphone in which one microphone is directed in the front, assuming that the speaker will be in front of the listener, and another microphone is placed at the back of the device, such as hearing aids or even in the Bixby kind of a speaker, whereas the second microphone will pick up only the noise and mostly not only the noise, mostly the noise, and therefore we can use the second microphone input for estimating noise and suppressing it. So third application is echo cancellation. So acoustic echo cancellation is very important in the media devices and automatic speech recognition devices, because consider a scenario. You have a speaker which is having built-in microphones and it is playing a song. You asked it earlier, Alexa, play a song. So it is playing a song, and next time when you are about to give a command to speaker, you will be speaking, and at the same time when the speaker is already producing some kind of music. So what there is a need for suppressing this background music in order to recognize the speaker's command, and this is done using acoustic echo cancellation. So there is already a pre-known signal, which is music signal, and it is filtered and removed from the microphone input to remove the echo. So again, for this application, the microphone should have low inherent noise. And the final application which I saw during my work at Samsung was beamforming for noise suppression and speaker and speech separation. So here there is a group of multiple talkers, and we want to separate out speech from different talkers, and particularly it should be speaker dependent speech separation. So here if the mixture is having more than two talkers, estimating each of the individual signals from a single mixture signal becomes very difficult, and therefore generally an array of sensors or array of microphones is used to capture multiple input signals, and then make this problem more solvable. So generally these array of sensors are placed on a very small area, and this requires the microphone size to be very small. So these applications which are based on beamforming require the microphone area to be very small. More recently, beamforming is also used in hearing aids for speaker separation and noise suppression. So the challenges become even more prominent because hearing aids inherently are very small devices which have to be put inside the ear of the user. So then making the microphone even smaller is required. So some of the recent developments involve MEMS microphone, that is micro electromechanical systems microphones, and these are very small in area. They are fabricated on a silicon wafer and are working principle wise. They are similar to condenser microphones. They have very low noise and power consumptions and are very precise and highly repeatable. So it becomes very easy to use them in beamforming applications. Then there are alternative speech sensors apart from microphones, which can be more useful in background noise, so that they inherently have a capacity to capture only the signals which is of interest and remove, not be concerned with the signals or frequencies which are having noise. These are sensors which can be attached to speaker's skin to receive directly signals from the throat rather than using a microphone. So these, some of them are bone conduction microphones, which can be attached to the skull, and as and when you speak, the vibration of your bone can help you detect what kind of speech is being spoken and to record it. But generally, these are very narrow band. But this property itself makes them insensitive to noise in other frequency region. Then there are throat microphones which can be placed on speaker's throat to pick up vibration directly from the vocal folds. And there is EGG, that is electrogrotograph, which measures the vocal fold area. So when we speak, there are vocal cords in our throat which vibrate, or there are two strings which are vibrating. The area between the two strings goes on increasing and decreasing periodically. And if we are able to measure this area, we will be able to measure what is being spoken. So this is EGG. This EGG is very useful in detecting voice activity for noise suppression application and for estimating pitch, because you are directly connecting it, estimating the vocal tract area, vocal fold area changes. You can easily estimate what is the pitch of the speaker. So if you connect this EGG to Lata Mangeshkar's G's throat, the pitch will be very different, and if you connect it to Jagjit Singh's G's throat, it will be very different. So then there are general electromagnetic movements and sensors or GEMS, which can be used to recognize transition between voiced and unvoiced speech sounds. So why we are interested in recognizing this transition between voiced and unvoiced speech sounds is that generally when we are speaking, there are some sounds like a, e, u, which are voiced, which involve active vibration of vocal cords, and there are sounds which are unvoiced like sh. These are the sounds which are unvoiced. So if we know that which regions are voiced and unvoiced, we know what are the high energy sounds like e, and what are the low energy sounds like sh. And these sounds which are low energy sounds are more susceptible to noise in the background, and you can prevent them knowing that these are the unvoiced sounds. You can develop algorithm to prevent suppression effect of noise on these unvoiced sounds. So some of the future aspects involve sensor miniaturization. There is a need for multiple sensors in a small area without any degradation in performance as well as low power requirements. So this is the one of the future aspect in speech signal processing area. Then we need smart and intelligent sensors, which consist of not only the sensor, along with it the microprocessor and related circuitry, which can directly give us a pre-processed signal. and can be used in variety of applications other than speech signal processing. Then there is a need for sensor fusion because of this IoT or Internet of Things, where you can have sensors not only from one domain, but signals coming in not only from one domain, but yeah, okay, 5 minutes, yeah. So multiple domains, and we can capture these sensors from multiple domains like image, audio, and integrate them using multimodal signal processing. So one of this recent coming up area is speech and EEG signals combined for BCI applications. So this was just a brief overview of women in statistics, women statistics in STEM. Generally, it is seen that women are less in the science technology field and more in biological fields. So we want them to more focus on engineering, mathematics, and science. And possible causes, some of which I felt were fear of isolation, stereotypical surroundings, challenges at workplace, or work-life balance issues. So how can we solve them? Uh, First thing is dismantle the bias, so it can start from very early on. Then we can have more mentorship and skill development opportunities for women and retaining them in as workforce in industries and academic places. And we should have flexible work environment with paid family leave and child support. So these are some of the possible solutions which can encourage women to continue or pursue their career in engineering and academic fields. Yeah, I think I'll be finishing here. Thank you so much. I So these are some of the mentorship programs and societies which will be useful for students. Particularly, we have EWST, which is a part of Women in Engineering IEEE Society. Then you have ISCA, Young Female Scientist Research Fellowship Program. Then you have SHE and SERB Power scholarships, which can promote women in science and technology. Yeah.
Thank you so much, ma'am, for such an informative talk. Now the session is open for question answering. You may feel free to ask questions.
Yes. Yeah. Yeah, my breath sound, right? Yeah, so there are two types to suppress this breath sounds. First thing, using a mechanical way to separate out the breath sounds. So generally singers use a perforated membrane to suppress that breath sound in a professional recording setup. And second thing can be, you can record the raw signal with the breath sounds, do a pre-processing later to remove breath sounds or high. So this is like unvoiced sound. So as I mentioned, this breath sound is not voiced. So if you have a setup to make a decision whether it is voiced or unvoiced, and then decide whether this pitch, right? So then you will have to do pitch detection. You record the signal from the microphone, detect the pitch of the speaker which is coming in. You can map the pitch, then target pitch, and then reconstruct the signal. So this comes under voice conversion. The way I said it, it seems very easy, but converting or changing the pitch without distorting the original signal is quite challenging. So it's a research area in which people are focusing on voice conversion, voice modulations. Yeah.
We can have questions from the students who have joined us online in an online mode.
Yeah.
So you can unmute your mic and we ask questions. Or you can put your questions in chat box as well.
So I used physical shielding to suppress my breath noise.
Okay, no question is there. So thank you, Dr. Nitya Tiwari, for an enlightening and entertaining session. We are grateful for the time and efforts you took to share your thoughts and experiences with our IEEE community, ma'am. To honor Dr. Nitya Tiwari, I would like to call Ms. Jyoti to felicitate her with a memento. Thank you, ma'am. Thank you, Ms. Jyoti. It's time to have some break. The refreshment has been arranged outside, so kindly please enjoy the break and along with the poster presentation. And we'll again meet at 11:45 hours.
Just wait for a minute. Before proceeding for the high tea, we'll be taking a group photo just outside the library main building. So please come up for a group photo session.
Am I audible now?
Am I audible now?
Hello, ma'am, can you hear us?
Yes, I can hear
Yes,
you.
I
But
can hear
my
you.
from where
But
should
Okay,
I
ma'am.
on my video?
From where should I on my video?
There is a option beside mute. I think one
Go
second.
to your no. And please go to your Google Meet link,
Okay, okay,
WebEx link,
start a video.
and there
Okay,
one option
start
you
a
have.
video.
Yes, ma'am. Now it's fine.
Yeah. Okay.
Yeah. Okay.
You can make your screen full also.
You can make it full screen, ma'am.
Okay.
Okay.
Ma'am, I think you have shared just the.
That one not, ma'am.
Ma'am, please share whole screen by going back to the WebEx. Please share the whole screen. Otherwise, it might be showing on your computer that it is full screen, but not on WebEx.
Okay,
You have to
join
share
the
the
meeting.
whole
I
screen.
have to
Join
join
meeting. I have to join
again.
again.
No, ma'am.
Ma'am, you can do one thing that you can share your slide to us, and we will process from our end.
I have already sent
I
a
have
mail,
already
ma'am.
sent a mail, ma'am.
Please check.
Okay, and you can
check.
make from here also full screen. One sample you can see where 40% is written. One side is plus, one side is minus. Beside minus, we have one structure. You need to click
Okay.
over there.
Okay.
Yeah,
Okay.
not plus. That behind that we have one tab like structure,
Yeah.
cup like structure.
Yeah.
Please click that. Not minus, cup like structure. You need to click.
Slideshow.
Ma'am, clap. Yeah, this
Slideshow.
one.
Is it okay now?
Now.
Is it okay now?
Yeah, it's now full screen.
Yeah.
Yeah.
And you are audible also. So, ma'am, we will start sharp at 11:45.
Yes, ma'am.
Yes, ma'am.
Okay.
Okay. So, be there with us. After 10 minutes, we will start.
Yeah, sure.
Yeah. Sure.
Thank you, ma'am. Thank you so much.
Please, you're welcome.
Yes. You're welcome.
इसको कट कर देगा ना
Yes, ma'am. अच्छा, नेक्स्ट बोलूंगी। 1 मिनट में अपनी पीपीटी को कैसे हटाऊं, कैसे स्टॉप कर दूं, है ना? स्टॉप वीडियो, नहीं, स्टॉप शेयरिंग। ओके, स्टॉप शेयरिंग। ओके, ओके, यू विल शेयर फ्रॉम योर एंड। ओके। आरती, अब आवाज मत करना। Oh, ma'am. How are you? Okay, not audible. We'll talk later. आरती करो, चलो। Hello. Yes, my mom. I'm here. Okay, ma'am.
Professor Shravani is working as an associate professor in Oriental College of Technology, Bhopal. I welcome you, ma'am. Ma'am, am I audible?
Yes, you are audible.
Hello, ma'am. Am I audible to you?
Yes, ma'am.
Ma'am, can you start now?
Okay, ma'am. Good afternoon, everyone. I would like to thank, first of all, Dr. Jyoti, ma'am, Table Mukherjee, sir, and Pavan Kumar, and obviously the whole organizing team of EWST 22. Myself, Shravani Mathur, and for today, I'm going to speak on the importance of various senses in today's life. Next slide. Yes, these are my qualifications and work experience. As uh, she has introduced me, she has told you my qualifications. I have done MTech from Power Systems in 2015 from RGPV Bhopal with honors in the guidance of Dr. Deepika Masant ma'am, and done BTech in Electrical Engineering in 2005 from Mahatma Jyotiba Phule, Rohilkhand University, Bareilly, UP. I've done my schooling I've done class 12th from Sacred Heart Center College. It's a UP board school in Sitapur in the year 2000, and done 10th from Army School, Gorakhpur CBSE board in 1998. Now come to my work experiences. Right now I'm working as associate professor. I'm collaborated with Oriental Group of Institutes, Bhopal, and has done worked as assistant professor in Oriental Institute of Science and Technology from March 2010 to 2013. And my first job was as a lecturer in Sri Ram Swaroop Memorial College of Engineering and Management. That's in Lucknow. I have started my job just after completing my BTech degree. And by luck, I was the first one in my batch to grab a job, just in the field of education. But I am really happy that I have got my job before everyone else in my class and in my branch. Next, please. Yeah, these are my international publications. I have done a lot of work on the on machines. Basically, my MTech belongs to the power systems. And in power systems, I used to work on various machines like asynchronous motor. Asynchronous motors, you can say it is induction motor also, right? And we all know that induction motors are used today in almost every sphere of life, every sphere of industry. As you all know, induction motors are there in your fan, obviously. Fan, simple things. So I have done a lot of work by using MATLAB simulation, and these are the examples of induction motor. These are my papers which are already published in IEEE Explore, Digital Explore in the year 2014, 16, and more. And some more international publications which are not in IEEE Explore, but these are published in various journals like IGERA or AJCT in the year 2017 and 2013. Uh, See, when we talk about the electricity, we all know that what happens to the electrical network as an electrical engineer, what we understand about a grid. Grid is, it's the combination of generation, transmission, and distribution of electrical power, right? And we all know there are so many generating stations which generate electricity like NTPC or NHPC. These are the NTPC means National Thermal Power Corporation. NHPC means National Hydropower Corporation. In NTPC, we use coals, right? It depends on the fossil fuels, coal, and then this energy is converted into electrical energy by use of boilers. When we heat up the water in the boiler, then the steam strikes on the turbines, and turbines are related to a shaft, and these shafts are further connected to AC alternators, right? So this is the process of generating electricity. Now, how it comes to you? It comes to you through transmission, right? You have seen various towers, various heavy electrical towers installed at every distance, at every, in rural areas, in your cities. Various huge towers and huge cables are there, huge overhead transmission lines are there, which used to transmit the electrical energy. Why I am telling all this to you is just the basic thing which every electrical and electronic students must know, and even the audience who is sitting in front of me, who can understand what is the main what I have done in my research work during my MTech. Actually, I have worked on machines, and machines are installed everywhere in the power system. And what is power system? I have just told you that power system comprises of generation, transmission, and distribution, right? So I explained the generation part. Now come to the transmission part. What happens? One, we install step up transformers which step up the power to the high voltage, because what happens, if while using high voltage we incur less losses and high efficiency of power transmission. High efficiency of power transmission, then it goes to the finally to the distributors like companies and industries and to your homes. So I have worked a lot in synchronous motors and asynchronous motors, that is induction machine. So these are my international publications in which I have gone through all these machines and power systems, because my specialization was that. And now come to my national publications. This is my Google Scholars, my Google Scholar ID is there. You can find it in my slide, and my ORCID ID is also there, as I have published a lot of papers and have done a research work. These are few of my national publications which I have done in India. Okay, next slide. Yeah, why we should go for the memberships of IEEE like institutions. We know that there are various societies which are concerned with researchers and academicians, which can provide a platform for you all to get connected, to share your ideas. And if you are working on some research project, then it will benefit you to interact with the same mindset people, right? So these are the few. I'm the senior member, and my number is already given in my slide, of IEEE, that is Institution of Electrical and Electronics Engineers. This society is doing a lot in the favor of humanity by making use of technology. That's why I have joined this technology, and because of that, I'm in front of you. I'm giving my views, how to join it, how we can work on sensors. I have a lot of, responsibilities in IEEE Madhya Pradesh section, as I am an executive committee member of IEEE Madhya Pradesh section. I'm social media coordinator of IEEE IRC. IRC means Industry Relation Committee Madhya Pradesh section, and a reviewer. I have reviewed a lot of papers for the Sage University in association with IEEE Madhya Pradesh. There are some few more societies also students can join. Institution of Engineers of India. As we are talking of engineers, as we are talking of, upcoming youth having a lot of energy and lot of zeal to do anything, to grow with some startup, to grow in some Maharatnas, Navratnas. So this is very necessary to become a part of these institutions and societies. It will you will get benefited a lot from it. Next, please. Next slide, please. Yeah, my role model, as we all know, Mr. Ratan Tata sir, right? Ratan Tata sir has indulged a sense of, ethics and innovation in the industry. He has provided almost 10 lakh employment to our youth. Okay, and they follow a set of various policies that helps their employees to retain in the company, and that's why he is my role model. Obviously, I think 99% of you also appreciates him, because he's the only industrialist. He's the only industrialist who have some ethics and who used to be there for you every time. Next slide. Electrical, yeah, my patent, I have patented electrical vehicle charging station with power measurement. We all know that we use petrol and diesels in our cars and vehicles, but we are switching to electrical vehicles. Why? Because it is the need of the day. Our fossil fuels are going to be exhaust at some day or another. But if we go to the go for electrical vehicles, then what happens? Electrical vehicle charging station with power management. See, there will be some charging stations when we use electrical vehicles. But with power measurement, what does it mean? Power measurement means we install renewable energy. We install solar panels at the charging station, and in addition to solar panels, BESS is also there. BESS is battery energy storage system, and by the combination of renewable energy and battery storage energy storage system, we can create a charging station by making use of PID controller. PID controller is pi derivative controller, and various current control strategies are used in this patent. It has been published, and it's in the invention category of electrical. Next. Yeah, some interesting facts about sensor field. We all know about sensor. What is a sensor actually? A sensor is a device that measures a physical quantity and converts it into a signal which can be read by an observer or by an instrument. For example, let's take the example of a mercury thermometer. What happens? When we insert the mercury thermometer to the skin of a patient who's having some fever, who's having some hot surface, then what happens? That it senses the hotness, it senses a physical quantity of that body, and it converts that signal into readable contraction of a liquid which can be read on a calibrated glass tube. We all know that. Okay, I'm just talking about very a very initial stage of sensors, as you are the undergraduate and postgraduate students. So I have prepared slides according to you so that you can understand what is exactly sensors, what are the types of sensors, and how it can be used for various purposes. I will talk you something about the various purposes. Now, types of sensors. There are two types, the active sensor and the passive sensor. Sensors that give a signal to the measurand. What is measurand? Measurand is the measurement quantity, quality, okay, and detects its reflection, and are active sensors. Requiring an external source of energy, they give a signal such as light, electromagnetic wave, radiation, and sound to the measurement object and receive its reflection, transmission, and absorption, and detect the feature quantity of the measurand. Passive method, on the other hand, passive sensors do not need their own source of energy. They don't have I have already muted. Hello, am I audible or not? Am I audible or not?
Am I audible? Yes, ma'am, you are audible.
Okay, there are some, they're not audible. So I thought, okay. Please switch to the next slide. Yeah, types of sensors. When we show some image, it's very easier to understand the things. See, what is active method? There is a person standing in front of a sensor. If we talk of infrared sensors, infrared is what? It's a radiation which is not visible, right? Which is not visible. So if a person is standing in the front of infrared radiation sensor, then and something wants to get inside that infrared, then obviously it will detect that some person is there or some object is there. And what is the property of a sensor? It converts it into a signal, and this signal is being displayed on somebody's mobile, or it can be displayed on some computer, so that the people sitting there is able to understand that there is something which is interfering the infrared radiations of my sensor. So this is the active and passive methods, as we all know. Come to the next slide. How sensor technology is beneficial. We all know that it accelerates process and make them more accurate. When we talk of sensors, it will tell you more accuracy, because unlike conventional analog sensors with no active components means there is no electrical power equipment in analog sensors, which allow them to make measurements and output values and digital data. As I am talking about a simple thermometer, see, when we talk of analog sensors, when we talk of the conventional sensors, analog sensors, we talk of measurement of temperature, measurement of pressure. Measurement of temperature can be done by thermometer. Measurement of pressure or blood pressure can be also done by some sensor. Now what happens when the analog sensor is put on a surface of it detects its environment and sends signals to the calibrated glass tube, which is there in the barometer also, pressure measurement also, and in thermometer also. But if we want to see it in form of a digital data, that means numerical display is there. So we use digital sensors also. These are not as conventional analog sensors, but these are digital sensors. So this make more precise and more accurate sensors. Now the second point is collect, process and access data in real time. It collects the data in real time. What happens? It senses a signal, or it senses something which is the change in its environment. It senses the change in its environment. Then what happens? It self-test, self-validate and self-adapt to the and give the result as used by the, as suppose in a huge industry, there are the points where the energy consumption is more, but how to compress this energy conservation? We can use various sensors. We can install various sensors in those portion where the energy is used in very huge. Yes, next slide. I will explain you in the next slide. It monitors process and assets accurately, reliably, and continuously. It used to monitor the process which is going on in some industry. It process something going on in a clinical medical institute or medical clinic, and its reliability is very much, and continuation is very much appreciated. It increases productivity and reduce total cost of ownership, because if we know where we are lagging in energy efficiency, if we can extract where we are lagging in energy efficiency, though at that point we can identify through the sensor. And what happens with continuous monitoring and data retrieval, process leaders can identify areas of high energy consumption. Means some engineers can identify the areas of high energy consumption by making use of sensors, and can take appropriate steps or measures to limit energy wastage. If we can find where the energy is being used in more power is used, then we can find out those points making use of sensors, and this will attend the engineer, this approach will help companies achieve sustainable development goals, SDGs, set by our United Nations as affordable clean energy. This will provide you three things. See, three things like affordable clean energy. if you know where are you lagging in energy efficiency, and if you work on it, then you will find three things. Affordable clean energy will be there in your industry, which is a requirement by United Nations SGD. SGD is Sustainable Development Goals, which every industry and a company has to follow, because there are a huge amount of carbon emission, and which is uh, you know it is yes, in global warming, it is very much giving to the global warming. So these few goals are set by the United Nations, which every industry has to accomplish. So these goals are what? Affordable clean energy. Affordable means less cost is there. Less cost is there, because we have sensed those part of energy where we are lagging. And second is industry, innovation and infrastructure. And the third is responsible consumption and production. Responsible means we are not going to harass our environment. We are not going to contribute to global warming. So these sustainable development goals have been set by the UN. Okay, next slide. Yes, benefits provided by the various professional societies like IEEE. If you are already a member of a IEEE society, you can recruit new members. You will provide some 25%, you can earn rewards. Your membership provides ways to get involved with technical and local communities, network with technological professionals, establish a professional profile highlighting your accomplishments. Means there are huge advantages of joining such societies, and you are seeing by your own that you are having interaction with industry experts and academia experts. So these all are the things which are beneficial for you all to join societies like IEEE. Next slide. Yeah, women should go for higher studies in different fields like engineering, science, and medical. We all know that in our country, our half population, see, I think only 10% of women are into the professional field right now, because there are few, which make them. But I'm telling you, you can choose from various core branches in engineering. When you go to engineering, I'm talking about women student, and of course boys also, because both are the audience, and we cannot work without both of them, right? So this is for both of them, and the whole webinar is for both of them. You can choose when you go for it, choosing an engineering as your career. What happens? You can choose various core branches. Most of the people today used to go to AI, ML, CS, but in my view, you can choose electrical, mechanical, or civil. This will open the door for the growth-oriented future for Navratnas, Maharatnas, as you know, Navratna and Maharatna companies of India, and also to the private good companies of India, like India and abroad, like Dilip Buildcon or Larsen and Toubro. This is about the engineering field, and if you are interested in studying science, then what happens? You can work as a scientist in various organizations like ISRO, or if you want to go to abroad, NASA is there for you. RRCAT is there for you in Indore, right? Raja Ramanna Center for Atomic Energy, and okay. See, I have talked about the engineering and science field right now, but I'm telling you, as I have started a career in teaching just after when I completed my BTech, right? At that time in 2005, MTech was not necessary for teaching, and if you have an MTech degree, then it's a benefit to you. So you can go in education field also. To my audience, this is for my audience. Now come to the medical studies. Medical studies is a very good field for especially girls. Like ma'am has said, there are some, there are some in mind that some people want to go in medical. It's good both for girls and boys, and you can become a gynecologist, dentist, ophthalmologist. Gynecologist, most gynecologists are males. It's a department of, yeah, it's most of the gynecologists are males in today's present era. Next slide. Yeah, fellowship and research programs in the field of sensor technology. For various our smarts undergraduate students, I'm talking of summer undergraduate fellowship in sensor technology provided by University of Pennsylvania. You can apply for the application. It is starting from 30th May to 4th August 2023. Okay, it will provide you hands-on research during the summer in the area of sensor technology. The second one is the Center for Biochemical Sensors, Imperial College London. Imperial College London provides a huge benefit for Indian students. As we all know, Indians are everywhere in the world because of their intelligence, because of their smartness and intelligence. So one PhD studentship in optical sensors by the Department of Chemical Engineering is available with tuition fee and living stipend fully covered. You don't have to give any fee if you are selected in that PhD studentship, right? It is open to all applicants, including overseas students, especially for Indian students, right? Only applications with an outstanding academic track record will be considered. The first and foremost thing for this PhD studentship is the student must be a very smarter and very intelligent person for uh, grabbing this studentship, right? This is the link for Imperial College London. You can go through it and search for the opportunities waiting for you. Next slide. Yeah. Enhancement of employment ratio of female students or working females in the academia and industry. First thing which we should do for our women, that most important thing in female life is work-life balance. If you provide flexible hours for working to a female employee or a girl, obviously she can perform in a better way. So flexible timings must be there, right? Flexible timings, flexible hours must be there. Then how we can encourage? So Indian government has provided some reservation to ladies also. For working women, there must be an option for paid pregnancy leave in every private organization also, as government organizations are already providing this paid pregnancy leave. But it's my suggestion that private organizations should also consider for this to retain the employment of female working females. It is the responsibility of the society, parents or spouse or in-laws to let them do all those things to move in their further career. There must be no biasing between a male and a female employee of any organization, no gender bias. So all these things are there to enhance the employment ratio of the female working candidates. Okay, next slide.
Sorry for the interruption, ma'am. Please try to wind up within 5 minutes if possible.
Okay. See, this is the introduction. No, come to the introduction slide. A sensor is a device that produces an output signal for the purpose of sensing the physical phenomena. In broadest definition, a sensor is a device. It's a machine or a subsystem that detects events or changes in its physical environment and sends the information to the other electronic equipment. Other electronic equipment has to be there to detect the signal which is provided by the sensor. Means sensor works with the combination of electronic equipment or device. Okay, we know that analog sensors such as potentiometers are still widely used. Their application include manufacturing, machinery, airplanes, aerospace, and wide range of other sensors other than thermometer, pressure and flow of liquid fluid measurement. There are other sensors like optical sensors for refractive index measurement, vibrational sensors for fluid viscosity measurement. Next slide. Sensor sensitivity and its huge manufacturing on a microscopic scale. We know that what is sensitivity? Sensitivity indicates how much its output changes, sensor's output changes when the input quantity it measures changes. It is a ratio of dy by slope of dy by dx, assuming linear characteristics. For instance, I'm giving you an example. If a mercury in thermometer moves 1 centimeter when the temperature changes by 1 degree Celsius, its sensitivity is how much? Its sensitivity is 1 centimeter per degree Celsius. Okay, now technological progress allows more and more sensors to be manufactured on microscopic scale. See, a very microscopic scale we can install our sensors. As you can see, this is the infrared sensors. It's a trans receiver. It has a light emitting diode. It has some microcontroller installed over there on a small chip. It's very small. That's why I'm calling it a microscopic scale. Okay, next slide. But as we are using huge, so we can install various small chips on huge, semiconductor. Now, chemical sensors, you can see the diluteness and the concentration of a liquid. This will tell you the pH value of a substance. So, chemical sensor will detect the pH value of a liquid, which will tell you about the acidity or alkalinity of that particular substance. Next slide. Yeah, biosensors. This terminology applies for both in vitro and vivo application. Next slide. MOS sensors. Now come to the MOS sensors and image sensors. How it can be manufactured. MOS technology means metal oxide semiconductor technology is based on the modern image sensors, including charge coupled device, CCD, charge coupled device, and CMOS sensor. This is used in video cameras. Willard Boyle has developed the CCD in 1969. As it was fairly straightforward to fabricate a series of MOS capacitors in a row. MOS capacitors in a row, we can fabricate a series of MOS capacitors in a row. They connect to a suitable voltage so that the charge could be stepped from one to next. Next slide. This is the image of video camera. Okay, biochemical sensors. We are talking of MOSFETs. We all know about the MOSFET. This is the gate, drain, source, and it's the line of gate oxide. That is, we generally use silicon. Silicon dioxide is used, and an NPN channel is formed for this MOSFET. Next slide. Yeah, ion sensitive field effect transistor. As I have told about the MOSFET, now it is, instead of MOSFET, it is ion sensitive field effect transistor. MOSFET is what? Metal oxide semiconductor field effect transistor, and ion sensitive field effect transistor. How is it different? Next slide. In my next slide, I will tell you. See, this is NPN channel. This is a gate insulator. This is silicon oxide, and an ion FET. There is a electrolyte. This electrolyte has a voltage, and this is the difference between the conventional MOS FET and ion based FET. Next. Thank you. Any queries? Next.
Thank you, ma'am, for a wonderful talk. Now the session is open for the question answer. You may ask questions from ma'am. Anyone? If online students want to ask any question, they can ask the question, or they can put their question in the chat box. Okay, if there are no questions, then we can proceed. Thank you, Professor Sharvani Mathur, for an enlightening and entertaining session. We are grateful for the time and efforts you took to share your thoughts and experiences with our IEEE community. We have arranged a quiz contest in an online mode, and interested students can join the quiz contest from the link and code which have been shared on the screen, or you can also join from the chat box. I request the participants to attend as per the instructions shared on the screen. Along with the quiz contest, we have also arranged a model presentation by the Kendra Vidyalaya students of IT Indore. After that, we'll have a lunch break from 12:30 hours, 12:50. Sorry, 12:50 hours, and we'll again meet at 14 hours. And yes, one more prize distribution will be from 4:45 to 5 p.m. The students who are sitting here can also join the quiz from their mobile or any device. For joining the quiz, you can go to that link which is being shared on the screen and you can enter the code. Or you can Google it, that link on Google.
If someone is having difficulty in joining, kindly you can just raise your hand. तो चले जाइए.
सिंपल सा है, गूगल पे इस लिंक को जब आप सर्च करेंगे ना तो वहाँ पे एक कोड डालने का आएगा, तो वहाँ पे आप ये कोड डाल के जब एंटर करेंगे तो आप सीधे क्विज में एंटर कर देंगे। फिर जैसे ही यहाँ से क्विज स्टार्ट होगी तो स्टार्ट होगा। किसी को प्रॉब्लम हो रही है तो
फोटो खींच लो.
डायरेक्टली बता सकता है ना, उसके बाद
फोटो खींच लो. फोटो खींच लो. Join my.
इस पे बोलते हैं बोल के
अरे वो कर रहा है, वो है, मैंने बोल दिया था किसी को डिफिकल्टी है. So I'll be starting the quiz sharply at 12:30. And in this quiz, the marks will be given on the basis of how fast you are answering the question. Like if all the students given 20 out of 20 right questions. Huh? School. सब उसमें एक ऑप्शन आ रहा होगा कि विच इंस्टीट्यूशन यू आर, तो उसमें स्कूल कर देना सब. अगर कोई लेट भी ज्वाइन करेगा कोई दिक्कत नहीं है, इसमें मार्क्स तुम्हें उसके बेसिस पे नहीं कि अगर मैंने अभी स्टार्ट कर दिया, जब भी तुम स्टार्ट करोगे जितनी जल्दी आंसर दोगे उतने ज्यादा मार्क्स आएंगे। जिसका ज्वाइन नहीं हुआ एक बार फोटो क्लिक कर लो, बिकॉज मैं स्टार्ट कर दूंगा फिर ये स्क्रीन हट जाएगा। विकास इधर आ जाना। सो नाउ आई एम स्टार्टिंग द क्विज। ये ज्वाइन कोड 386651। इधर भेज दियो, इधर भेज दो। जैसे चाहिए। इसका फोन में कंटिन्यू। Participants are increasing. It is now 92. Earlier it was 30. So give the answer as fast as possible. Win the prizes. सबसे जल्दी और सबसे ज्यादा करेक्ट। तो इसमें अगर सेम अमाउंट ऑफ आंसर भी सही है तब भी डिफरेंशिएट कर लेगा। Time question will be seen only for 30 seconds in that. Sir, you can also try it. Amber Khan is at the top right now. Anya Mukherjee is also coming upwards. Abhijit, Joha Afzal. जो गूगल करेगा, जब तक वो गूगल करेगा तब तक उसका क्वेश्चन निकल चुका होगा, तो गूगल ना करे। So we have crossed the 100 participant mark. एक सेकंड तू चैट उधर दे दे जवाब या रुक जा तू दे दे 386651 एवरीवन ही करते the code is 386651 And now in first position we have Amber Khan, Anna Marine Georgie, but it can change. One point. Now finally, Amber Khan rank has been degraded by Sakshi Sharma. Uh, 126 total participants are there. I think ये था नहीं. Those who have completed the quiz can go outside and see the models also. बैग इधर छोड़ के जाने जा सकते हैं अब बैग छोड़ के भी कोई इधर लेके नहीं जाएगा
ये बंद कर रहे हैं क्या क्विज 50 तक बोले थे, अभी तो 10 मिनट ही हुआ।
स्टूडेंट्स के खत्म हो गया, ठीक है, डन हो गया।
अच्छा
62 डन वाला भी आ रहा है ना, 84। ओए इंदिराज आ गया।
उसका बस वही रुक गया वो। अच्छा ये क्या, टू में इतने सारे क्यों है, सबका सेम पॉइंट है क्या?
बट टाइम वाइज
अच्छा ठीक है।
तो पहले 3 दे देते हैं। ये कैसे कंटेक्ट होंगी, बट सीरियस
Please help me. Those participants who are still answering the quiz, uh, I I request them to complete it. Means we will be closing the quiz in 5 minutes. So
12:50. At 12:50 you have still 10 minutes.
10 minutes. Yeah. Okay.
You still have 10 minutes. If you haven't joined till now, you can join right now also. It is in the chat box. How to join the quiz. Once all the participants have submitted the quiz, then this quiz will automatically end. Like it is already shown on our screen that 109 out of 130 were done.
हाँ तो रही हेलो हेलो हाँ अरे आवाज
मीनू को दे देंगे।
मीनू नहीं बोलो
ऑन कर
हेलो मेरे पास स्लाइड है
स्टार्ट वीडियो में टैच स्क्रीन करते हैं। हम लोग पहले वीडियो स्टार्ट
क्या आवाज आ रही है आपको
Hello.
Hello.
Hello, ma'am. Am I audible?
Yes, you are audible.
Can you please share slides?
Okay. Is it visible to you?
Yes, ma'am.
Okay. Hello.
हाँ तन्वी
Hmm.
हेलो तन्वी
हाँ.
इसमें जो IEEE नैनो टेक्नोलॉजी काउंसिल लिखा हुआ है ना उसको सेंसर लिख दो सेंसर्स
ठीक है, मुझे एक्चुअली यही फॉर्मेट दिया गया था.
कोई बात नहीं इसमें सेंसर्स काउंसिल बस और नीचे रीजनल रिसर्च सिम्पोजियम ही हटा दो
पूरा ही.
हाँ ये हटा दो एनटीसी भी जो ब्रैकेट में हटा दो आप
जी.
IEEE
अच्छा,
सेंसर
सॉरी
काउंसिल के आगे
सॉरी.
एनटीसी जो है वो हटा दो आप
हाँ हाँ, ठीक है.
ठीक है गुड गुड थैंक यू
Sir, Start 2 बज गए. I hope you all enjoyed the lunch break. So I welcome you all again to the session. Now it's time for virtual roundtable. For this, we have invited Dr. Tanvi Parikh, Dr. Priyanka Kajal, and Ms. Suchita Singh. First, I would like to invite Dr. Tanvi Parikh, Corporate R&I, Materials Characterization and Laboratory, Solvay R&I Center, Vadodara, Gujarat. Welcome, ma'am.
Thank you.
Hello, everyone. I'm Dr. Tanvi Parekh, and I'm presenting on this in IEEE Sensor Council for Student chapter in IIT Indore. So, before starting the topic, I would like to first introduce myself. Currently, I'm working as a senior research assistant with Solvay, which was established in 1863. Before this, I did my PhD from IIT Indore in metallurgy engineering and material science. And before that, I did my MTech.
Excuse me, can you just full screen the presentation?
Okay, yeah, sure.
And if your network permits, we would like to also see your video if it is feasible to you. It is still in normal mode, I think.
No,
Screen
no.
is
Wait, actually, I was just opening the video.
sure, sure.
That's okay. So this is my introduction. So before MTech, I pursue my Bachelor's of Technology in Electronics and Communication from Rajasthan Technical University, Kota. And my aim is to develop new materials that fulfill the never-ending dawn of more intrinsic power-hungry batteries and which trigger more sustainable future. Actually, today, what industries demand is for sustainability, and which is like for a green planet, sustainability is very important for us. So, what I believe is positive thought, our charger for our enlightenment that enlightens our life. So, till we breathe in this beautiful planet, we have a hope, and that hope is our charger. So, starting with, first of all, I would like to introduce that what makes sensor feel interesting for us. Basically, in industrial, sensor is very important. Currently, for measuring the change in temperatures, pressure, or any of the change like resistance change or anything, we require sensor. In industrial, it is a day-to-day requirement. So sensor in industry allow us to check the transition and whether there's a like if we have to determine in metallurgy engineering or in material science whether for some sample like what is a change in a position of the sample or what is a change in length, height, or external dislocation or anything. So we can measure this, detect this, and we can analyze this with the help of a sensor. But these sensors also help us to digitalization and improve the productivity of the industry. So, with a aim for better productivity and excellent mass production, sensor is a very important technology. So, to power these sensor, we require some power system, and these power system we have a battery as a power system, but sensor as a small thing. So we require something which is very small and which can power it. We can fit in a sensor. So thin film battery provide us a new opportunity and new possibility to sensor technology. And with this, with the help of this, we can use this sensor technology in miniature devices also in industries, and this power up excellent work. In a consumer sector, it offers a blendable but robust solution for integration into smart gadgets and a wearable. So, for a smart world, we require a smart sensor, and for this, we require a solid state thin film battery, a new generation battery that is a future for sustainable industrial production. For example, the commonly used thin film battery in a sensor are wireless sensor and RIFD tags. We know in wireless sensors, we need to send the messages. So in that case, we don't have a wires. These are wireless sensors. So in any time, if there is a lack in transmission or recipient, so we can't afford that. In this case, we require that kind of power technology that can power it at without halting. So in this case, thin film batteries are high power density battery that helps to power the wireless sensor, and the same is the case with RIFD tags. Moving forward, we have a now I would like to discuss the benefits of the professional industry as IEEE give me chance to speak on this talk. So what's the benefit of these professional societies on young mind? Basically, these professional societies are primarily based on education and informational thing. So here, the thing is key, they allow us to publish our work professionally, that help us to develop also our work, that it raise the public awareness, and also the awards we get.
Sorry for the interruption, but we can see your slide changing. It's still in the third slide.
Okay.
So if you are sharing it, then share your whole screen, not just the application, then it will change properly. Oh. Yes, ma'am. Please reshare it, and when you click share, then just share the whole screen. Yes, ma'am. Now I think even with full screen we can. Thank you, ma'am.
Okay, so I'm talking about the IEEE or professional societies similar to IEEE. These professional societies provide opportunity to researchers to in both in academic and industrial level, so that they can publish their papers, they can develop a professional excellence. This raise public awareness, and also the awards given by these professional societies. These awards inculcate a new think in other young generations, and it arose a great awareness, so that other people also want to go in this field. So IEEE is that basically it inspire global community to innovate for a better future, and this helps by the citation of publications, conferences, and technological standards. In short, I can say it's a trusted voice for engineers, computing, and technological information around the globe. Here are some of the list of fellowships research programs in India. Basically, Tata Innovative Fellowships, SBI Postdoctoral Research Fellowship. These are fellowships are both for girls and boys. But government introduced a special fellowship, especially for women scientist program, gender advancement for transforming institution like Geti, and Kiran scheme. These schemes are especially for women that promote women who have break in their career, or due to some certain reason they are not able to proceed for their higher education. So we have to thank government, and we have to promote women to join these programs and more participate in these. Moving forward, basically here we are talking about women education. So there are basic obstacles in women education, so we have to overcome these obstacles, then only women can approach for the fellowships which government provide, or women can approach for higher education. The obstacles like social biases, gender biases, lack of mentorship, or other things like we have a poverty, one of the reason. The thing is ki, when family tend to afford not afford resources for boys, but not able to afford resources for girls, reason they have not that much resources they can provide to two children. So these are also the causes that lack women from the higher education. Other thing is sexism in the workplace, and a lack of female leaders. So at a workplace, women are underestimated, and they are not promoted at the level which they have to be. So to overcome this, we have to encourage women in education. For these societies are there, we have to build a organization such as Girl Scout. It helps the girls to learn science, technology, engineering, and mathematical fields, and promote more and more awareness in these fields. They to encourage curiosity, establish visible role models also is one of the things we can encourage women. Also, we have to expose to other resources such as Association of Women in Science and Society of Engineering. These all societies working for women towards higher education. We can start conversation with families also. We can start conversation with girls, those who want to stop their higher education but, due to some certain family reasons. Thank you for this. I would like to end my presentation here only.
Thank you, ma'am, for informative talk. Now I would like to invite Dr. Priyanka Kajal, Senior Scientist, Ananya Vijaya Consultancy, LLP, Bangalore, India. Welcome, ma'am.
Hi, thank you. Hello? Is my screen visible?
Yes, ma'am.
Okay, thank you. So, hello, good afternoon, everyone. Today we all are together here to motivate our young researchers or young engineers to step into the field of sensors and similarly in other engineering fields also. And on the basis of the sensors field, today I'm going to discuss about one of the exciting light-based sensor, which is called solar cell, and especially perovskite solar cells. Today I'm going to present. So I am Dr. Priyanka and working as a senior scientist. So the brief outline of today's presentation is background and my research journey, then the sensors and their importance, then solar PV, a light sensor, and what are the research highlights, and how you all the new young girls can participate in it and take it further, then how women can be benefited in research and how women can be supported in engineering education and also in industries. So my background, you see that in India, I'm basically from Haryana, and from there, from district Kurukshetra, and from there, from a very small town, Ladwa. So, and my engineering journey is my BTech was from Electronics and Communication Engineering from Kurukshetra University. Then MTech was from NIT Kurukshetra along with the CSIR Chandigarh, and the PhD is from IIT Mandi along with NTU Singapore. So the beginning of my research life was also with the women's and very enthusiastic women faculties and scientists. Firstly, I was supervised by Professor Nina Jaggi from NIT Kurukshetra, and during my master's, I got 6 months to work with her in my research, and at that time I worked on the nanomaterial synthesis. Then the same work I carried forward during my internship time at CSIR Chandigarh, where I utilized those nanomaterials for the gas sensing application with the help of the nanofibers under the supervision of Dr. Pooja. So followed by this, I worked in IIT Mandi, joined in IIT Mandi as a PhD scholar in 2016, and where I worked on the perovskite solar cells, electroluminescent displays, and some inks. And followed by my further PhD work, research work I carried out at NTU Singapore under the supervision of Professor Nirpan Matthews, where I worked on preparation of the screen printing inks and their utilization for the solar cells and the module fabrication. And currently, I am associated with the AV Solar Consultancy, and he is my boss. And together, along with the ISC, we are working on building a perovskite solar cell startup in India. And this is some highlights of the work going on over there. We are working on the up to the A4 size substrates, ultrasonic spray coating technique for the tin oxide deposition. Similarly, the perovskite layer deposition by the slot die coating. And these are some of the achievements during master's and PhD and post-PhD. So now let's come to the main topic, because we are discussing on women in sensors. So firstly, why sensor and what are sensors? So you all use this for your senses in whole throughout the day, like taste, smell, touch. All these are the basic sensing. And similarly, you see around you, like when you see the sunflowers, they turn their face according to the direction of the sun. And sometimes you have seen some plants also, if you touch them, they respond accordingly. So that is called sensing. So similarly, there is perovskite, there is solar cell, or I'm talking about on one particular technology only. So the solar cells, they also, when there is sunlight, they actually, with the help of that, generates the electricity. So it's a type of the sensor only. So some advanced type. And you might have seen that when there is sunlight, these solar cells take that energy, and from that generates the electricity, power your houses, and sometimes you give to the grid as well. So we can say the sun is for all. And similarly, the research in sun, or I can say the solar or sensors, is also for all of you. And what is like the basic thing about the solar panels or the solar cells? You might have seen installed near around you. So there is a solar cell layer, and which is enclosed in between the adhesive films. Then there is glass sheet and back sheets, frame, junction box. All these things are connected together, and the solar panels are there. So according to your research or according to your interest, like you all are on the young stage or growing stage, and if you want to work in it, you can pick any topic and you can work on solving various issues related to this in the society. So I will now talk about the different technologies of the solar cells, because we should be aware of all these also. So now, like silicon solar cell technology, you all might have seen. But similarly, if you see, based on the materials or based on the structure, we have different other technologies. So that is multi-junction solar cell, single junction crystalline silicon thin film, emerging PV technology. And among all these multi-junction and single junction gallium arsenide based are actually very costly techniques. Then silicon solar cells, which we are using, are around 27 or 28%. But now, like, their efficiency increment is very less. Similarly, the thin film technology. Thin film means you just take some solution and just coat it, like you do paint brush coating. That type of technique it is. So you just prepare some solution in the lab and you just coat it. So accordingly, it's classified into two categories, thin film and emerging PV. And among these, in the emerging PV technology, perovskite solar cells have achieved the highest efficiency so far, which is 25.6%. And similarly, tandem structures, which is like silicon, and on the top you are depositing another solar cell, that achieved more than 30% efficiency. So what are these architectures? Like which one is getting higher efficiency and which one I selected, all these things. So the architectures are, the classification is very simple. There is planar structure, there is mesoscopic, triple mesoscopic, and tandem. And in these planar and mesoscopic is further classified as PIN and NIP structures. So what is that? You have a substrate. So in solar cells, what you do, you take one transparent electrode and you take one opaque electrode. So you have a substrate, glass substrate, that is the transparent substrate. On that you have a conducting coating TCO, which will act as a conducting electrode, transparent conducting electrode, and then you deposit your layers. Similarly, among all these, I selected triple mesoscopic perovskite solar cells during my research. And the fabrication process is very simple. You have this compact TiO2, meso TiO2, ZrO2, zirconium oxide, carbon. All these layers you screen print and then sinter. So you can see in the picture, one layer is deposited. Then we do the screen printing and another layer is deposited on the top. And then we infiltrate perovskite in this. So, but the challenges are the infiltration issue, low VOC, and the absence of the absorption. So I will I'm just adding only few research work I have done in this technologies so that students can get some information. So one is about the carbon paste engineering. So as I told you that there is one transparent electrode and one opaque electrode. So in the solar cells, generally people use silver, gold, which is very costly material. So as an alternative, another electrode material which people are working on is the carbon. So carbon you all might have seen when you burn something, there is carbon. So similarly, we have some special carbons which we buy from the market and prepares inks. Like you have seen the picture, that graphite, carbon, black, zircon. So we mix the things in the ball milling jar and prepare the ink, and then we just screen print it. So after screen printing, we have to after screen printing all the layers, we do annealing and infiltrate the perovskite. So depending on this, we observe that the perovskite interaction with the different carbon blacks is different, and that the same thing we checked with the device performance. So when you are measuring the solar cell, you have to see the JV, current density, and the voltage characteristic. And accordingly, you see that how much performance you are getting from the solar cell. Similarly, you compare all the parameters, and we found that, okay, so depending upon the selection of carbon black, we can actually vary the performance of the solar cell. Another work which is in the engineering side is on the fabrication side. So when we are infiltrating this perovskite, we saw that we can't control the infiltration properly. So what we saw is, like a layman, how a layman can see that the device is going to work or not. So by drop casting, either it's spreading or not. So, and then it's crystallizing on the top or it's infiltrating inside. All these things we checked this. So this is called screen printer. Like I said, I showed you guys earlier that the fabrication process. So this is screen printer. We put a screen there, we put ink, and then with the help of squeezy and blade, we transfer the pattern, like the ink on the bottom side. So this is the like print we get. So in this, just the engineering part we were doing is what is the role of the pressure on the printing and how it's affecting the perovskite infiltration. So we saw that the more pressure we are applying, more closely packed layers are forming and poor infiltration is happening. So like I can show you here. So this was the architecture. And when we saw that the more HP is high pressure, LP is low pressure, low, medium, and high. So when we pressed it more, the less perovskite was going down. So in the LP, the whole structure is yellow. You can see HP, it's somewhere it's yellow, and there are some remaining areas where the infiltration was not good and it's deposited on the top. So this was the engineering side we were doing there. So accordingly, we performed the aging analysis and we saw that those who have the structures which have the perovskite deposited on the top actually are less stable and degraded very fastly. Similarly, we performed the XRD analysis. So like some of you are school going or college going students, so you might have read about the crystal structure, X-ray diffractions and all. So that thing we try to see that if my material is on the top, can I detect that, or is it fully infiltrated inside the device? So that thing I calculated with the help of XRD, and then the device performance analysis, and then use the same methodology from both the research work which I showed to make the modules of 100 centimeter square and achieve the efficiency of around 10.27%. So in the summary is just with the help of pressure, we try to control the infiltration process. So these are some of the other research work highlights. Sorry. Yeah. So one is about the module fabrication. One is about the ink or the paste engineering for various application, machine design, then electroluminescent displays. You just again screen print the layers and make your structure pattern in between, and then you can glow it according to your wish. Similarly, spray optimization, and you can make inks by your own and then utilize them to coat the larger areas. And about supporting women for the higher studies in different fields and their increasing their participation in industries, I feel like they should be treated equally. Also, women should never feel like they are inferior. If they have some curiosity, they feel something wrong is happening, any type of thing, if they want to learn something, they should come forward and ask the things. And the candidates selection in the job or any platform should be on the basis of their performance, not on the basis of their gender. And there should be some scholarship for the women who are studying in the universities, and also the school going girls, so that their families can also be motivated to send them to pursue higher education. And there should be adequate transportation facilities in the remote areas, so that girls can freely go and they will not be dependent upon their family members to like take them daily to leave to the university or the college. And also there should be security for the women's, and there should be action oriented policy, so that in case of any harassment reported, quick action should be taken. Thank you. Any queries?
Thank you, ma'am, for informative talk.
Thank you.
Ma'am, queries will be like at the end of the session.
Okay.
So
I'll stop sharing.
and at last, okay, ma'am. And at last, for this virtual round table, I would like to invite Ms. Suchita Singh, Labour Inspector, Indore, MP. Welcome, ma'am.
Good afternoon, everyone. First of all, let me introduce myself. I'm Suchita Singh. I'm currently working as Labour Inspector in Labour Department. It comes under Ministry of Labour and Employment. And I did my engineering in electronics and communication from Indira Gandhi Government Engineering College, Sagar. It was a kind of remote place, so we did not have much resources over there and infrastructure. So we struggled hard to get the resources and learn things, but somehow we managed. Yes. So next slide, please. Yes. Next slide. Yes. So my engineering journey, I told you about this, and then after my engineering, I started preparing for to get into some PSU. I prepared for GATE for 1 year and then could not make it. So of course, I was an engineering graduate, so I was good at some non-technical subjects without making any special efforts. So I entered into some non-technical exams and qualified preliminary exams also. So that boosted up my confidence, and I thought of getting into this. So I started preparing for, but competition here was also too much. So it was not easy to get into this government service. So I qualified one exam of state level, MP state government service, to get into MP state government service, and qualified it and got the position of labor inspector over here. And I got the sixth rank in state MP state. So this was kind of one of my achievements in my life. Next slide. Yes. So as a labor inspector, I work here for the welfare of labor categories, and also the employees who are working in private sector whose salary limit is less than 24,000. So people are not much aware about this department. So and when they work in private sector, they also face many challenges there, like they are not getting proper salaries, and the provisions that government has set for the for the employees in private sector, that the employers must follow for the welfare of their employees. People are not aware about this, so I'm here to as I can see that there are some entrepreneurs and some people who are working for startups here are also participating in this conference. So I'm with you all for this. If you're working towards it, if you face any challenges in doing your business and startups, you can always contact me, and you can get my contact details from IIT coordinators. So one should never stop dreaming. I also never did. I after getting into this service, I also thought of paying back to the society. When I was growing up and I was trying to settle my career and fulfill my dreams, society and this environment has contributed a lot. So I feel like we should also pay back in some terms to them.
So I'm also being a part of some non-profit organizations. There's non-profit organizations who are working towards consciousness, raising the consciousness level of the people, and as well as the environment for conservation of environment. So I'm also working with them also, along with working for my department is kind of working for the downtrodden class, the labor class of the people of this society. So my job is also kind of social work, and as well as I'm also working with some other some NPOs to contribute towards this environment also. Next slide, please. Yes, and personal and professional. If we talk about personal and professional growth, when talk about professional growth, government is digitizing their working strategy. Everything is going to be digitized. Earlier, there had been provisions of offline. When a business is established, they have to get some license from government sector. So that procedure had always been an offline process. But as government is moving towards digitization, everything is moving towards becoming online. So these procedures have become online. We also have to upgrade ourselves on professional front. We also have to upgrade ourselves, our technology knowledge. Also, when I had been an engineering educator, that helped me a lot getting into this technology and understanding it and growing into it. And when you have new skills, you also grow on your own. Like when you get some promotion chances, you can also show your skills. Like if you have extracurricular activities like sports benefits, you also get some chances or by government that gives you some extra benefits for your promotion, as well as some getting some increments. And about mental insecurities also, like when we work in field, when we work, we also work on stopping of child labors and bonded labors in our department. So when we go out to rescue one child labor, when we find one, there's much pressure. Sometimes there's much pressure, political pressure, and some other kind of people also try to stop us from doing it. So these are some challenges that women, especially women, face it. As some people. Sorry for little interruption. Really sorry. Yes. So when we go for some child labor rescues in field, people try to put some pressure, political pressure. We also face some other kind of pressures. Especially women also face this kind of challenges, because as Dr. Tanvi also said that there are some gender biases that are always felt by women, but they should not. Women should not get afraid of this. They should also always face them. And I also did it. I also faced many challenges while working with in this department. But it always works. It takes time. It takes some dare to face the challenges, but it always works. Next slide. Educational society always helps in making a better society. Like I had been, if I talk about myself and about everyone who is educated, it creates a skillful and well aware human being. So they can get more opportunities if they are educated, more opportunities, and create a better society. Like if you are working on your own field, as well as if you want to pay back to your society, you can also work with some other establishments and some other NGOs and NPOs for the betterment of a society. Next slide. Next slide. there are certain schemes going on by government. The people are not much aware about it. There are some college students also here, so I can tell them about these schemes. As government has some schemes like scheme for higher education. People who are registered as building construction workers, their children get scholarship for higher studies. Uh, we just went through one case in the current year that our department has provided a scholarship for abroad studies to one student whose father was a building construction worker. So you can go through the labor department website of labor department, and one can go through the scholarship processes. You can always approach it. Government has some certain schemes for underprivileged society. So you can always go through labor department website and get into it. Next slide. Yes, supporting women for feminist society is very important. Like as I told you, the cases when I go to field and convincing people about following the laws is very hard. Like I had gone through one example, one case when uh, I went I went to an industry for inspection, and I found that they had been following the bonus rules as set by the government for a long time, but no one was there to check it that they are doing it right or not. So, when I went through their documents, and I found that the documents had some fault. They were not aware about it. They were not doing it intentionally, but they were not aware about the provisions. So they were paying the bonus at the rate of 8.50% of their salary, but as per provision they had the liability to pay it to the 20%. So the workers and laborers were getting a very less amount as per government laws. So I told them about the provision, actual provision, and it was very hard for me to convince them for the payment of due amount that was due to on them for the payment towards the laborers, and as well as their other employees who had their salary limit less than 21,000. They also fall in the under the category of labor laws. Less than 24,000, 21,000 for bonus act. So it was very hard for me to convince them, but somehow I managed to convince them, and uh, uh, I got that due amount paid to the laborers, and it was very satisfactory for me that I did something for the downtrodden class and class of the society. And it was there was just a coincidence, and when I visited that firm 1 year after, coincidentally there was a random inspection, and I visited that establishment once again, and the manager of the industry told me that thank you so much, ma'am, that you let us know about the actual provision. I got to do something good for my labor. That definitely motivated them to work harder and get more output out of our industry. So this something that I did for the just downtrodden, underprivileged society of class of the society. And towards this feminist society, people always have to support it. Like when women are out for some work, they have to face some challenges. So government also needs to support us. Like, we are not allowed to go with someone else and go with a team. We have to go for inspection all alone. So some people are never so cooperating, and sometimes they misbehave with us. So government should make some flexible rules so that we can go with one or two people, or with a police team when we go for child labor rescue, with a police team, so that we don't have to face those challenges that we face right now. Next slide. Yes, government always needs to provide some better resources to women. When we were in college, we did not have much accommodation in hostel. So safe and more hostels with more accommodation needs to be provided by the government. Also, the transportation facilities should be better so that women do not feel unsafe while traveling. These are certain challenges that we always face while studying, and as well as while working also. Okay, that's all from my side. Thank you so much. Thank you.
Suchita ma'am, can you hear us? Repeat your question.
Hello, Suchita ma'am. I'm repeating the question. There are many companies who prefer male candidates over the female candidates because they need, because it is a field job, and they think that women cannot do this. So, what are your views on this?
I'm sorry, I could not get your question completely. I just had an interruption on internet. Can you please repeat your question once?
Okay. There are many companies, PSUs, or startups, we can say, who prefer male candidates over the female candidates just because they think that women cannot do the field work or cannot do the efficient work efficiently. So, what are your views on that?
There's no such thing like this. People try to put pressure over you, but it's always up to you, like to prove yourself. Like when I was about to join this job, people told me also that it's a field job and then you will not be able to survive in this. But I proved myself. I proved myself. I did whatever.
Hello, ma'am. Your audio is not clear.
Next question to Priyanka and
Okay, I will ask Tanvi ma'am and Priyanka ma'am. After BTech, there is a question whether to go for a job or a higher study. So, what you can suggest, or how can we decide whether to go for a job or for a higher education? Tanvi ma'am, can you hear me? Dr. Priyanka?
Hello?
Yeah, can you hear me?
Yes, I can hear you. So it's a very good question, but I would again say it depends on the person. Like they want to study ahead or they want to go in job. Because if I talk from my experience and some of other people I know their experience, so they always like what you feel you want to do, you need to go ahead in that and you'll definitely get success. So I don't know what to say on this, but I would say it's more about the person's like will that what they want to do.
गुड मॉर्निंग मैम माय क्वेश्चन इज दैट कि फैमिली सपोर्ट है कि नहीं करती नहीं करती द फैमिली आर नॉट सपोर्टिंग गर्ल्स फॉर द एजुकेशन इन हायर एजुकेशन the mindset of the parents are is the same in the classical they not support is a comparison to boys and girls they support boys for the higher education not girls so what's our views about it
That is true. That same thing I also have seen on various places. So one thing is from the girl side also she need to come ahead and talk on this matter that she want to study. Another thing is the people around, when they see that this type of thing is going on, so they should also participate in this, so that the the girl child can also go and study and can achieve her dreams. Similarly, our policies, the government policies, they should add some fellowships. I feel like scholarship is, maybe it's a monetary thing, but I have seen the people started sending their kid, especially daughters, to the school for higher education after they started getting the scholarship. So I feel like these things should be added. So required to be from everyone, like from girl, also from the society and from the government point of view.
Thank you, ma'am.
Thank you.
Hello. May I ask a question, ma'am? Hello, Kajal ma'am. Can you
Yes,
hear us?
yes. Yes,
ma'am.
I can.
We have a few stereotype thinking actually in our society or in our education. Uh, so I'll talk about generally in education system. We have a stereotype generally thinking related to the girls is that girls are good in chemistry and boys are good in physics or maths. So what is your opinion about this point?
It's not true. It's not true. Anybody can do anything. It's so similarly, like when I was studying, people used to give this suggestion that, hey, why being a girl you are going in engineering, why you are going in industry? They should be in the education sector, they should become faculty or the school teacher like this. So that type of thing will come. But like all those girls, young girls who are here, they need to be determined, they need to be like what they want to achieve, they need to be very clear on it. So I think after this the society will stop interfering if student will decide herself that what she want to do.
Ma'am, there are girls from BTech and MTech here in the audience. So, can you suggest some fellowship or scholarship which they can apply for
I
for
actually
their higher studies?
Yeah, so I'm not aware of many. Like when I was doing the BTech, so there is GATE exam which you all can give on the basis of your whole BTech studies, whatever subject you studied, and you can get the fellowship for the higher education. Also, you will get a very good institute. Other than this, you can give some net exam or yeah, or also you can apply, look at some fellowships from the DST, even IEEE also you can approach. And there is one more woman fellowship, I forgot, sorry. So like if you search, there are a lot of fellowships which are specially for empowering the women and to encourage them to go ahead. And yeah, you can apply. So GATE is for higher education if you want good institute also, like IITs, NITs or ISC, along with fellowship. So you can go accordingly.
Okay, thank you, ma'am.
Any questions from audience? Online? In online mode, participants, you can ask question by unmute yourself or you can write in chat box. If no further questions are there, then we go for.
Then we'll, okay. Thank you, Dr. Tanvi Parikh, Dr. Priyanka Kajal, and Ms. Suchita Singh for your time and efforts you took to share your thoughts and experience with the IEEE community. Now we'll start our next session at 3 p.m.
Thank you all.
In continuation with today's event, we have arranged a talk on technical workshop. For this, I would like to invite Dr. Shalu Rani, research scientist, University of Glasgow, UK. Ma'am, are you online?
Yes, I am online.
So I would like to brief introduction about her. Dr. Rani received her PhD degree in nanotechnology from Indian Institute of Technology, Roorkee, India in 2022. She is currently a research scientist at the University of Glasgow, UK. Her research interest includes advanced flexible supercapacitors, micro supercapacitors, lithium-ion battery, nanomaterial fabrication and characterization, and MEMS devices and sensors. Her research work is published in well-reputed IEEE journals, including IEEE Transaction in Power Electronics and IEEE Transaction in Electron Devices. Her research work based on ultra-stable supercapacitors for wearable electronic also appeared in Hot Topics, Carbon, Graphite, and Graphene by the Advanced Electronic Materials, Ville. I welcome you, ma'am. Ma'am, you can share your slides.
Thank you. Is my slide visible?
Yes, ma'am.
Please starting with video as well.
Ma'am, please start your video as well, if possible.
Okay. Hello, everyone. First of all, I thank IEEE Sensors Council for inviting me to speak in IEEE Women in Sensors. I will speak about flexible supercapacitor for powering wearable sensors. Okay. This talk will be on the technical side. Sorry, my slides are not changing.
Ma'am, you have to share your whole screen so that the slide will change once you do the full screen.
I have shared my whole screen.
Now it is visible.
Now it is visible, ma'am.
Okay. The title of my talk is Flexible Supercapacitors for Powering Wearable Sensors. Here I will discuss the need for energy storage, then the introduction of supercapacitors, their working mechanisms, their types, and various designs of supercapacitors. After that, I will discuss the fabrication of supercapacitor devices, followed by their applications in wearable electronics and sensors. First of all, why there is a need for energy storage. As we all know, the world's population is increasing day by day, and therefore the requirement of energy is also increasing. And the consumption of large amount of conventional sources of energy, such as fossil fuels, are also increasing. So we have to depend upon other alternative renewable sources of energy, such as solar energy, wind energy, hydropower, geothermal, and nuclear energy. But some of these resources are not available at all the times. Like sun does not shine at all the times, wind does not blow at all the times. So the energy generated from these resources needs to be stored in some energy storage devices. This is the Reagan plot, which shows various energy storage devices where first of all, we need to understand what is the specific energy, or we can say energy density. Energy density for an energy storage device explains how much energy a device contains. And power density, or we can also say specific power for a device, explains how quickly a device can discharge its stored energy. Currently, batteries are the commercialized sources of energy that can provide power to various electronics devices. But batteries also have some limitations, such as their power density is low. Their cyclability is poor. They can run up to thousands to 5,000 of cycles, but not for longer, up to lakhs of cycles. They are bulkier sources of energy. Moreover, they are incompatible and non-integratable with flexible and wearable electronics and sensors. All these limitations of batteries can be fulfilled by using supercapacitors as the energy storage device. First of all, we need to understand what is the supercapacitor and how it is different from a conventional capacitor. As we all know, the conventional capacitor consists of two conducting plates which are separated by a dielectric medium or an insulator. On the application of an external voltage, there is a polarization of charge occur at the interface of these both electrodes. However, in case of supercapacitor, there is a layer of electrolyte sandwiched between two high surface area electrodes. Please note that the surface area of these electrodes should be very high, up to thousands or more meter square per gram. And there is a separator is also there, which separates these two electrodes and prevents them from short circuiting. On the application of an external voltage, there is the formation of electric double layer at the interface of electrode and electrolyte. And the thickness of this electric double layer is represented by D, which is generally in the angstroms. So this is the reason the capacitance, it is known as a supercapacitor, because its capacitance value is very high from capacitors because of the high surface area of the electrodes as well as very small thickness of the electric double layer. The components of a capacitor includes a substrate. Substrate should be conductive in nature. We can also call it a current collector. Then an active material should be deposited onto the surface of the substrate using some deposition technique. And the characteristic of this active material should be, it should have high surface area. It should be porous in nature with voids or gaps. It should have good ionic or electronic conductivity. It should be stable or nature friendly with low cost and abundant in nature. The electrolyte for the supercapacitor should have high ionic conductivity, thermal and electrochemically stable. It should have higher potential window because the energy density depends upon the potential window. Higher is the potential window, higher is the energy density for a supercapacitor device. The electrolyte should have good mechanical strength, especially for a flexible and wearable devices. It should have non-corrosive in nature, and it should be safe because it needs to be used in the wearable application. So safety is the most important concern for supercapacitors in flexible and wearable applications. The separator for supercapacitor should be porous in nature. It should have high ionic conductivity, but electronic insulator. It should be electronically insulator, because if electrons pass through the separator, then short circuiting of these two electrodes will be there. As per the working mechanisms of supercapacitor is considered, there are generally three types of supercapacitor. First one is the electric double layer capacitor. This I have already discussed. In the electric double layer capacitor, there is a formation of electric double layer at the interface of electrode and electrolyte on the application of an external voltage. And absorption and desorption of this electric double layer occurs during charging and discharging respectively. In the electric double layer capacitors, carbon-based materials are generally used as the active materials. So due to simple adsorption and desorption of charges at the interface, its stability and cyclability is very good for the ADLC's capacitors. But there one limitation for ADLCs are their low energy density. The energy density can be improved if, in addition to the electric double layer adsorption and desorption, there is a transfer of electrons from the interface of electrode and electrolyte, which occurs in the pseudocapacitors. In pseudocapacitor, metal oxides or conducting polymers are used as the active materials. Metal oxide are the transition metal oxide with the variable oxidation states. And the energy, due to the transfer of electrons, their energy density is high in comparison to the ADLCs. But due to high due to less conductivity of these metal oxides, pseudocapacitors suffers from poor cyclability or stability. So these issues of EDLCs and pseudocapacitors can be resolved by using hybrid capacitors, which are the combination of EDLCs and pseudocapacitors. They are also called asymmetric supercapacitors, where one electrode can be of EDLC type or carbon-based material, can be of metal oxide or pseudocapacitive material. Moreover, the composites of EDLCs or pseudocapacitors can also be used as the active materials. So the hybrid capacitor works on both electrostatic as well as electrochemical charge storage mechanisms. Various designs of supercapacitor. There are various designs of supercapacitor devices reported in the literature. First one is the conventional supercapacitors. They are sandwich type supercapacitors and they are non-flexible in nature. In these devices, generally graphite or metal such as nickel, stainless steel, titanium foils or foams are used as the substrate. We are focusing on the substrates in this slide because the architecture of a supercapacitor depends upon the nature of the substrate. Substrate is the backbone of a supercapacitor device. So here metal foils are used as a substrate, therefore they are non-flexible in nature. And in between these metal electrodes, there is a layer of electrolyte sandwich between them. Other one is the flexible supercapacitors. There are various types of flexible supercapacitor. First one is the sandwich type supercapacitor. They are flexible in nature because in these devices, flexible and porous metallic substrates such as flexible stainless steel meshes and foams can be used. Moreover, flexible polyethylene terephthalate substrate can also be used, and flexible carbon paper can also be used as a substrate in these type of devices. Other category for the flexible supercapacitor is the in-plane supercapacitor. They are in this architecture. It is a comb structure. There is a comb structure type of design in this type of supercapacitor, and these two combs act as the two electrodes for the device. And in between these two electrodes, we can see a little bit of gap in between these two devices. The layer of electrolyte is sandwiched between it's drop casted over this device, which fills all the gaps as well as on the surface of these electrodes. So the advantage of in-plane supercapacitors are they are in-plane devices. There is no usage of any separator in these type of devices, as separators are used in these devices, sandwich type supercapacitors. So because of elimination of the separator, the thickness of these devices are greatly reduced. And due to this small gap between these two electrodes, the ionic diffusion length is also reduced and ionic diffusion process is enhanced. So the electrochemical performance of these devices are greatly enhanced in comparison to sandwich type supercapacitors. Moreover, the thickness of these devices are very less, therefore they can easily be integrated on a chip with other electronic circuits or devices to act as a self-powered source of energy. The substrate in these devices are flexible PET, PDMS, or flexible copolymer films or freestanding films can be used as a substrate in these in-plane supercapacitors. Next is the textile-based supercapacitors. They are very attractive type of supercapacitors for wearable applications. In these devices, carbon cloth fibers or yarns and CNT fibers can be used as the substrate. These substrates are very highly flexible and conductive in nature. Moreover, they can easily, the device using this substrate can easily be attached to a wearable fabric or a cloth that can act as a variable source of energy. And last category for the flexible supercapacitor is the yarn, fiber or cable shaped supercapacitors. They are the highly flexible type of supercapacitors where highly flexible and conductive carbon yarns, CNT yarns, can be used as the substrates. Sometimes metal wires or thin metal wires can also be used as a substrate such as platinum, nickel or stainless steel. But the disadvantage of using metal wires is that they are not much flexible as much as the carbon or CNT yarns. Moreover, the metal cannot be take part in the electrochemical conduction, so they adds the extra and unnecessary weight to the device. Now let's see how a supercapacitor device can be fabricated. First of all, a substrate needs to be selected, which should be conducting in nature. After that, an active material is required. Why we call it an active material? Because it takes part in the electrochemical active conduction. The active material should have high surface area and good conductivity, as I have discussed previously. After that, slurry of the material needs to be fabricated, where material is mixed with a small amount of binder and an conducting additive in NMP solution. And this prepared slurry is coated onto the current collector, or we can say substrate, to make the active electrode. And after that, electrolyte fabrication is performed. There are generally three types of electrolyte: aqueous, gel polymer, and solid electrolyte. The aqueous electrolyte does not be considered safe for wearable applications because there is an issue of leakage in these aqueous electrolyte. Moreover, they are corrosive in nature, so they corrode the active material as well as substrates. Therefore, in the wearable application, gel polymer or solid electrolyte can be used. After that, device can be fabricated by sandwiching a layer of electrolyte as well as separator between these two electrodes. The last step is the device characterization. The supercapacitors can be characterized by using cyclic voltammetry, galvanostatic charge discharge, and impedance spectroscopy. This is the fabrication process for the conventional supercapacitors. However, there are various active electrode fabrication techniques reported in the literature, such as vacuum filtration, electrodeposition, electrophoretic deposition, screen printing, sputtering, chemical vapor deposition, layer by layer self-assembly, and in situ hydrothermal. These techniques can be used to fabricate the active electrodes for energy storage devices. And the morphology and surface of the electrodes fabricated using these techniques can greatly enhance or affect the electrochemical performance of a supercapacitor device. However, the value of capacitance from a single device is very less in the millifarads to tens of farads. So large number of devices can be connected in series or parallel to get a higher amount of power or energy. And another solution is to increase the surface area of these electrodes. The surface area of these electrodes can be increased, but due to this, the specific capacitance of the device can also decrease because the weight of the active material is increased and the specific capacitance can be decreased because they are inversely related. So with increase in the surface area, the resistance of the device can also be increased. So to prevent the increment in the resistance, one strategy is to deposit current collector grids onto the surface of these electrodes by using a deposition technique. In this case, screen printing technique has been used to deposit current collector grids onto the substrate surface of the textile.
Hello. Hello, ma'am. Ma'am, you are not audible. Ma'am, you are not audible.
Hello, am I audible?
Yes, ma'am.
Okay.
Yes, ma'am.
The interface between these current collector grids and composite textile can be seen in the FESCM image. A large number of supercapacitor textile can be woven into a wearable T-shirt, and they can maintain their electrochemical performance under various bending conditions. Moreover, the series connected supercapacitor textile can power 44 LEDs under deformation condition, as can be seen image in the figure D. Now let us see the fabrication of a yarn supercapacitor. This is one of my work. In this device, first of all, a bare carbon yarn has been selected as a substrate because it is highly flexible and conducting in nature, over which active materials which are TiO2 and multivolt CNT have been deposited using electrophoretic deposition technique. Then a layer of gel electrolyte has been coated over this active electrode, and then two electrodes will be twisted against with each other and again coated by a layer of gel electrolyte to fill the remaining gaps. The surface analysis of the electrodes and device can be performed where the uniform deposition of all the elements of the active material can be seen. Then the electrochemical analysis of the device can be performed using cyclic voltammetry and galvanostatic charge discharge. By utilizing the discharge time from the galvanostatic charge discharge, the value of capacitance has been calculated and plotted with respect to the different current rates. Moreover, the device displayed good flexibility, good stability up to 10,000 cycles on a single current rate. So this shows the good stability of a yarn supercapacitor device. Moreover, the flexibility of the device can also be investigated on various bending angles by performing the cyclic voltammetry. The practical applicability of the device can be investigated where large number of devices can be connected in series. In this case, 3 devices have been connected in series, which increased its voltage window up to 4 volt. And these could provide a power to a red LED for up to 5 minutes during different bending. Parallel provide power to a wear device. This piece of cloth with the knitted yarn devices can be called as energy storing fabric, or it can also be integrated with an energy harvesting fabric, or we can also say turboelectric nano generator with a wearable electronics part. So this whole piece of work can be known as a self-charging chargeable supercapacitor. In this type of configuration, the human motion or vibration of human body can be converted into electric energy by using a turboelectric nano generator, which can be stored into a supercapacitor fabric. So this can act as a whole device can act as a self-chargeable supercapacitors or self-chargeable wearable electronic systems. During the motion, when up to here we can see the voltage profile of 3 yarn supercapacitors charged and discharged by the turboelectric nano generator at different motion frequencies. When motion frequency up to of 5 Hertz was applied, the supercapacitor devices can be charged within 2000 seconds and discharged within 800 seconds. And when frequency of this motion is increased from 5 Hertz to 10 Hertz, the charging time is reduced. These devices can be charged in up to 800 to 900 seconds, and discharge time remains the same. So these can be charged and discharged depending upon the frequency of motion of the human body. Now the main challenge in the wearable supercapacitor is the mechanical robustness, or we can say the flexibility. The supercapacitors needs to maintain their electrochemical performance during various bending, twisting conditions to act as a flexible source of energy. So in this regard, washable supercapacitor has been fabricated for the first time, where CNT wires has been used as the active material and PVA KOH polymer sheet has been used as the solid electrolyte. This CNT wire has been knitted into this PVA KOH sheet, so it is named as SUCAP. This CNT wires has been knitted in the horizontal as well as vertical direction, as also they can be knitted into 3 dimension. After that, the device has been laminated by using polymer sheet and a lamination device, and then the packaged device can be integrated into a wearable cloth. So further, the characterization of this device has been performed by washing the device for a large number of washing cycles. Here we can see the device maintained its electrochemical performance, or after 10 washing cycles, the device maintained good capacitance retention. Moreover, the cyclic voltammetric curve of the device does not provide very much change in the CV curve for before and after different washing cycles. So this is the one of the strategy to fabricate a flexible supercapacitor that can be washable. So the application of supercapacitors in wearable electronics and sensors can be seen here. In plain supercapacitors can be used in the band of the smartwatch, where large number of devices can be connected in series. Moreover, large number of in plane devices can be connected to sensors or energy harvesters to act as a self-powered source of energy. The micro supercapacitor device can also be attached to a pacemakers. Currently, batteries are using as a source of energy in the pacemakers, and batteries have a limited life cycle. So to replace a pacemaker, surgery of the patients needs to be performed. So micro supercapacitors are the future of these devices, because they can run up to with the pacemaker as the micro supercapacitor as the energy sources. They can act as a lifelong source of energy in these devices. Further, yarn supercapacitors can be connected into a wearable fabric. They can provide power to a smartwatch or a portable device. And textile supercapacitors can be used to power a wearable healthcare device, where large number of devices can be connected in series or parallel, depending upon the requirement of power. So in summary, flexible supercapacitors can act as an energy storage component to power a multifunctional electronic system, where they can be integrated with energy harvesters or other components. The main limitation of supercapacitors is their low energy density. So current focus of research should be the enhancement of their energy density by developing new high surface area and porous materials, redox electrolytes, and versatile device designs. Achieving mechanical robustness and durability is a great challenge in wearable supercapacitors. So this can be achieved by careful packaging of the device or by developing devices that can be washed. And more research efforts should be focused towards the integration of flexible supercapacitor with other electronic devices. Thank you.
Thank you, ma'am, for your wonderful talk. Now the session is open for the question answer.
Hello. Thank you for the wonderful talk, Dr. Shalu. Can you let me know about Tribo Nano generator a little bit, because I was not very much familiar with that device.
Yes. Triboelectric nanogenerators are the devices which can convert mechanical energy into electrical energy. Like when a device tank has been connected to a human body, and when we run or walk, the motion is generated. So this motion or frequency can be connected into electrical energy by using different energy generation mechanisms. And this energy can be stored in a capacitor device.
Thank you, Shalu, for the answer.
Thank you.
Online audience can ask the question by unmuting their mic, or they can put their question in the chat box.
Dr. Shalu, Ankita here. I just want to know that your all work is based on the multi-wall CNT. So can we use the single wall CNT and single wall CNT perform better than multi-wall CNT or not? If you use single wall.
And my work was not on the multi-wall CNT. My work was on TiO2 nanofibers. With the small amount of multi-wall CNT, I added 2% of multi-wall CNT into the TiO2 nanofibers here in this.
So what's the role of multi-wall CNT with TiO2 nanofiber?
Yes. The role of multi-wall CNT is because TiO2 nanofibers has poor electronic conductivity. So little bit of multi-wall CNT has been used into the solution which has been electrodeposited onto the carbon yarn. And this multi-wall CNT can act as a current collector between TiO2 nanofibers. That can act as a charge carrier current collector to transfer the charge from up to the carbon yarns. Moreover, multi-wall CNT can also improve the adhesion of the active material over the surface of the current collector. So these were the tasks for the multi-wall CNT in this case.
Okay, thank you.
Ma'am, there is one question in the chat box. How is the twisting of carbon yarn done? Is it done manually, or how we will ensure the reproducibility? It is done manually.
Yes, the twisting has been performed manually, and the reproducibility can be achieved by like when we fabricate large number of devices and we test these devices, the reproducibility has been achieved. I have achieved it in my case.
Good morning, ma'am. Ma'am, my question is that we can create a super battery for the energy consumptions in electronic vehicles.
Super battery for electronic vehicles. Yes, that depends upon application to application. I am focusing on the wearable applications. For the yes.
Yes, ma'am. Today requirement of energy is more and more, ma'am. Requirement electrical.
Yes.
And we cannot provide that energy.
Yes, electrical vehicles require more amount of energy for which batteries can be fabricated or developed. But in these type of applications, the requirement of power is very less, from milliwatt to microwatts. So that can be fulfilled by micro batteries, or sometimes micro batteries can also not be found compatible with these devices. So flexible supercapacitors can be used to power these type of devices.
Thank you, ma'am.
Thank you.
Okay, there are no further questions. Thank you, Dr. Shalurani, for an enlightening and entertaining session. We are grateful for the time and efforts you took to share your thoughts and experience with our IEEE community. Now I would like to invite Dr. Anupama Thakur, Postdoc Research Associate, IUPUIE, USA. I would like to give brief introduction about her. Dr. Anupama Thakur is currently working as a postdoctoral research associate funded by the National Science Foundation in the Department of Energy at Purdue School of Engineering and Technology at Indiana University, Purdue University, Indianapolis, USA. She earned a gold medal in Master of Technology in Nanoscience and Nanotechnology from Punjab University, Chandigarh, India in 2016. She has also earned a gold medal in Bachelor of Technology in Electronics and Communication Engineering from Akal College of Engineering and Technology, Eternal University, Baru Sahib, India in 2014. She is a well-established young nanotechnologist in the field of advanced nanomaterials and material science for various applications, including materials for clean hydrogen energy generation, carbon capture and utilization, chemical sensors, photoelectrocatalysis, extreme environment, and actuators. She has published more than 34 international high-impact publications, 5 patents, 12 book chapters, more than 20 conference papers, and delivered more than 60 oral talks. She has attained more than 750 citations to her published research contribution. I welcome you, ma'am. Ma'am, you can please share your slides.
Thank you for the kind introduction. I'll be sharing my screen. I request for I'm not able to share my screen.
Ma'am, you can send us your PPT so that we can share from our end and you can suggest us go to next slide.
Sure. Just let me rejoin once. 1 second.
Yeah. Or you can try once. Maybe this time you can connect.
Ma'am, you can share your slides.
Yeah, I'm sharing my slides with you.
Yeah.
Sorry for the inconvenience. I think some issue with my Mac. Wait.
Just try once. I think you will be able to share the slide, or you can just mail the slides to us. We can run the slides on your behalf. Ma'am, am I audible to you?
Yes, I've shared my slides with Shruti. So maybe she can help me to share.
Okay, ma'am, we are just looking over that and we will once shared it.
Yeah, sure. Thank you.
Ma'am, I think you may be able to share by yourself. We have made you co-host. You can share by yourself also.
Yes, I'm just trying. 1 second.
Ma'am, your presentation is maybe logged. It we can't just share it.
Okay, I'll just join from a different laptop. Just give me 2 minutes.
Yeah, ma'am. We can hold.
Yeah.
अभी तो मॉर्निंग के वो 6 बज जाएंगे तो हमने अपने
Ma'am, your slide is now visible to us. You can continue with the presentation. Yeah. Ma'am, it's all. Ma'am, just make it full screen if possible. Uh, yeah. Okay. Thank you, ma'am. Now you can proceed. No, unmute yourself. I think you are mute.
Am I audible now?
Yeah, ma'am, you are completely audible to us.
Okay, so greetings everyone, and sorry for keeping you holding for this time. So talking about and jumping directly to my presentation, I'm Dr. Anupama Thakur. I'll be presenting my research contributions and some research insights on nano-engineered functional materials for smart sensors. And I cordially thank the organizers for giving me this opportunity to share the stage with eminent speakers and talk about my journey so far in, sensors field. So moving ahead and, talking about the walkthrough of my presentation. So I'll be talking about the background and journey of, my research so far, and will be sharing a spoonful of experiences with you all. I'll be talking about, a woman, my research canvas, talking about our contributions to the field of sensors. We'll be taking you all towards women and sensors ecosystem, which requires connect, engage, and collaborate mission that we all can contribute to. We'll talk about outreach and volunteering. We'll talk about how we can promote diversity and globalization in women and sensors field. And we'll also take you towards various funding and opportunities. So talking about background and tribute to cultures, family, and friends and regions, I come from Himachal Pradesh, and I talk about, various, stories that a common, small state can, encourage others. So evolving from gushing waters and sun-kissed mountains of Himachal Pradesh, Queen of Hills, Shimla, we promote culture, lifestyle, and beauty. And I also thank my family, which has been a support system in multiplying my joys. Talking about my education diaries, my high school from Shimla moved for, studies for, undergraduate research at Eternal University. Then headed further to Punjab University in 20 and completed my master's in nanotechnology in 2016, and further embarked a journey on pursuing doctoral research at CSIR, which is a national lab at Chandigarh. So during all these canvas of, various standpoints where I have been working, I have been contributing largely as an early career researcher in solar energy harvesting field, specifically green hydrogen production, working on sensors for water quality monitoring, sensors for air quality monitoring, and photoelectrocatalysis, and also nanoengineering of materials and various pollutant and, degradation of various industrial pollutants in water. So far, starting my journey from synthesizing nanomaterials to, transferring few of our technologies to industry. And now presently I'm working on vaccines for green energy and environmental solutions. So I'll be briefly discussing upon research highlights of our contributions and encouraging, basically the mission of my talk will be to encourage each one of you to build a connect in women in science ecosystem, and also propagate the, knowledge and the sharings that we learn today from this workshop. So with this, here is the canvas of my research contributions and distinctions. So far, as I discussed, we have been, contributing largely to energy and environmental solutions, promoting nanomaterials for their proper utilization in green energy systems, as well as, water quality monitoring devices. So with this, I'll be moving ahead and talking about nanomaterials for sensors. So what makes these nanomaterials more special in this field? So firstly is the nature of nanomaterials, talking in terms of their properties, talking about the properties at nanoscale, their optical, electrochemical, and their tunable properties. So with the customization that nanomaterials has offered based on the design that one needs to, tune them for various applications. So that is the beauty of these materials. So with these, we can, create or basically design sensors, and the basic components of any nano material enabled sensors talks about the type of nanomaterial that we choose to design a sensor, the recognition elements that we, we functionalize over these nanomaterials, and also the signal transduction techniques. So as Dr. Shalu, talked about various transduction techniques and also pseudo capacitance based materials. So in my talk, my focus will be on talking about optical and electrochemical sensors, where we talk about designing materials and how we can tune their properties to selectively target and analyze for water quality monitoring. So with that base of my talk, I'll be, discussing the figures of merit that make these nanosensors qualified enough for monitor nanosensor. So we need to understand that what figures of merit are we looking into. So the first one that is very important is obviously selectivity of a nanomaterial towards a selective analyte. We talk about high sensitivity in terms of how qualitatively it can detect the analyte. We talk about in various, quite number of right terms that are used in nanosensing, talking about limit of detection, limit of determination, which is the minimum detection limit to which the nanosensor is sensitive for any analyte. We talk about limit of quantification, is again related to limit of detection. However, the standard, the mathematical formula for calculating limit of quantification is 10 times the standard deviation of a material towards a sensitive electrolyte, sensitive analyte response. We also talk about, relative standard deviation, how the material behaves in a number of, scans that we test into. We talk about precision of a nanosensor, and we also talk about the accuracy of a material by repeatedly checking its, response towards analyte. So based on all these figures of merit, we evaluate a material for its selective and sensitive response to any analyte. So by understanding these figures of merit, we can, qualify in designing some, sensors for water quality, air quality, or various other analytical responses. So highlighting briefly upon our contribution specifically towards chemical sensors for water quality monitoring. So I'll be briefly discussing these research works which are already published. And you all can, if you have any doubts in any of these, I can surely help you. You can just write me an email. So briefly touching upon these and starting from first. So as I mentioned that to design any nanosensor, the first thing that we need to opt in is the type of nanomaterial that we need to work on. The second thing, which is very important, is the recognition element, which is basically a chelating agent which helps you to promote selectivity towards the analyte. And the third is the transduction technique. It could be optical, electrochemical, or even could be magnetic, or any kind of element that we need to add, or a transducer basically, to convert that response into any form of qualitative form of signal. So herein we have contributed largely for designing sensors which are optical in nature. So as an optical probe, I would say we have used carbon quantum dots as a base material, which is a zero-dimensional material. We have utilized its optical properties in order to study the response towards various analytes. Now, as we know that, when we synthesize these zero-dimensional materials as carbon quantum dots, they have basically hydroxyl and carboxylic acid as the surface functionality onto them. So now these functionalities offer, I would say, multiplex response towards various ions for water quality monitoring, be it iron, be it copper, and even some other heavy metals. So in order to promote selectivity, we have used various kind of chelating agents, or I would say binders, onto these surface functionalities of CQDs or carbon quantum dots. And based on that, we have tuned their response towards various analytes. So on the first work, which is highlighted on my screen, talks about arsenic detection by decorating it with a thiol functionalized group onto carbon quantum dots, which promotes its better selectivity towards arsenic. In the second work, we have decorated our material with nitrogen rich, which is a Schiff base that we synthesized, which act as a supramolecular agent, which is decorated onto carbon quantum dots, which showed a selective response towards selenium ions in water. In the third work, we have used the inherent property of the precursor, which was used to synthesize carbon quantum dots, which was rich in amine groups. And based on that, we were able to achieve selectivity towards selenium, again in water. And in the third work, the major idea of all the works that I'm showcasing on my screen was basically funded by a CSIR project. And working in a national lab, we had an opportunity to contribute to projects which promoted specific goals. So basically in this project, the main focus of designing these probes was to synthesize a material which was synthesized by green precursors. So in the fourth work, we have synthesized carbon quantum dots from a citrus limpta waste, which was rich in citrus content, and that we have utilized the surface functionalities of the inherent material which was used to design these carbon quantum dots for the iron sensing in this method. So by working on these materials, we were able to detect diverse, variety of heavy metals in water and quantify them, and also we further fabricated devices based on their responses, which I'll be showcasing in my coming slides. So in the next slide, again highlighting upon various carbon quantum dot based probes which we have synthesized. So again, as I mentioned, that we synthesize them from various green precursors. So in this part of my research, we had contributed towards synthesizing carbon quantum dots from waste papaya peels by pharmaceutical drugs. And also they showed their response based on various, functional groups which were added to them by for example, in the work wherein we synthesized carbon quantum dots from papaya, they were decorated with EDTA as a binder, which showed selective response towards chromium. And based on this, we were able to detect chromium in a wide detection range from 10 to 1000 ppb in water. And the limit of detection was in the range of the WHO limit, which is permitted for chromium in water. So similarly, in one of my work, which is highlighted on my screen, we spoke about designing nanocomposites, which were electrochemically sensitive towards selenium, which was again, which is basically again water pollutant. So herein we synthesized gold, basically nano gold, and decorated it with nano ZNO. So as we have ZNO, which shows in line to literature, we understood that ZNO has a good binding energy towards selenium. So we utilized that binding chemistry of ZNO for selenium, and reported this material for voltammetric sensing of selenium in water. So similarly, in line to all of these research contributions, we, after synthesizing these materials and establishing these materials for various analytes for water quality monitoring, the next step was to devise device development and fabrication, and also to prepare these technologies for industry collaboration. So based on that, we fabricated devices for water quality monitoring. So in this part of device that we developed at the CSIR lab, the major focus was to establish, basically utilize the idea that we worked with nanomaterials and integrate it with electronics in order to develop a device which is portable, which is low cost, and which can basically help us to for the real-time sensing of selenium in water. So based on that, this fluorometric device for selenium detection was developed, and the sensing material which was used was the ultra sensitive material with nitrogen functionalities onto carbon quantum dots as a sensory probe, which was integrated to the system. And based on that, we were able to qualitate the selenium content in water. So in the next part of device development, we also based on the carbon quantum dots that we had synthesized at lab scale, we showed a response which was colorimetric in nature for arsenic detection in water. And based on that, we were able to again have the technology ready for industry, and we demonstrated this on paper-based substrate by decorating these carbon quantum dots onto paper, and further showing their response towards colorimetric detection of arsenic in water. So again, the LODs of this material were in line to the WHO limit, which is permissible for arsenic in water. So we were able to quantify arsenic in the permissible limit. So in the next technology that I have been involved was basically, now as we worked on various optical sensors, colorimetric sensors. So now the main hurdle that we faced during this journey was that why not to have a digital readout system for all these colorimetric probes that we are working with. So we also contributed in designing a digital readout, which was in collaboration with a team which was working on, app development. So we showed all our sensors. We used paper strips and which showed different responses for, various heavy metals. So we incorporated that paper-based strip and calorimetric response and integrated it into an app. So we were able to further quantify a digital readout which was integrated to a mobile by a app that we developed, which was HMI Sense. So based on that, the RGB values of the complete response of sensor was able, a digital readout was provided by this app. So based on this, we were able to quantify, and it is more, user friendly. So with all these investigations, starting from, lab investigations, we were able to transfer these technologies, or to prepare these technologies to a readiness wherein the industry can opt for. So with all this journey that I have been, working on, that these all things and research contributions position myself in women and science engineering field, which is again a diverse ecosystem. And I congratulate each one of you who are contributing to this. And with this, we all, we need to, again, connect, we need to engage, we need to collaborate through this medium, and we can definitely promote women in sensors. But we need to understand that what are the points where we all can contribute more and, have more reasons to collaborate, more reasons to connect and propagate this revolution. So as we all know, there are several reasons why women needs to opt for STEM and should be given an opportunity to opt for STEM. So first thing that we qualify in, we are capable. We can opt for STEM disciplines. We can opt for women in sensors. We can also opt for various other disciplines which are inclined to women in STEM. Second, we believe that we are shining star. We have various, opportunities, multiple job roles, and also we need to focus on proper nourishment of girls and women. So that's another very important point. We should be empowered. So these are various reasons. However, based on all these reasons, still there's a STEM gap that is, we all need to contribute to, fill this gap. So when we talk about this STEM gap, so we look into the numbers, and presently this is a recent report. So we talk about the contributions coming from women in diverse fields. So still we see the numbers in engineers and architects is still 16.5. However, the numbers in biological scientists, chemists and material scientists, the number is increasing. So again, congratulations to everyone who are contributing to this field. But still, we see there's still a gap, and to contribute this and to close this gap, we all need to come together. We need to build that strong connect. We need to work on various, barriers that prevent women from opting for STEM disciplines. So that's the, major point that we all need to work in. We need to work on furnishing the skills, building confidence to succeed in STEM fields. We need to work on STEM education, support girls for starting from their early education, and basically highlighting majorly the major point after qualifying into these diverse, fields. The main thing is we need to work on improving job hiring for women in these careers. That's another very important point which can propagate women in STEM education. So with all these points, the major three barriers that I feel and I'm discussing on this platform are the lack of encouragement that we all need to work on. We need to work on talent deficit. Again, that's where we all can contribute to. And the third and very important point is to have, role models in life. So that's very important. And as a technical workshop, I'm not just proposing the barriers. However, I'll talk about briefly about solutions that we all can talk and remove these barriers. So the solution to remove lack of encouragement is we can invest in infrastructure in order to make inclusive access to technology. So that's very important. We need to integrate technology in classroom to industry. So it's not just academia. We need to build this integration of technology, and to build a strong connect, we need to talk in both aspects, in academia as well as in industry. We need to provide hands-on training, which can provide real-world experience about STEM fields for women. By doing this, definitely we can organize some kind of summer camps, workshop, and after-school activities. And I really appreciate the IEEE Sensors Women in Sensors, chapter is really doing great at IIT Indore, and they are largely contributing to fill this gap of, lack of encouragement. So this is really of great success. We need to talk about talent deficit. So we can definitely remove these barriers by providing funding opportunities, by providing scholarships, by which we can fill this gap and definitely contribute to overcome this barrier of talent deficit. So we can provide various, qualitative workshops where we can talk about how we can improve the skills in women and girls to, promote STEM educations. That's very important. And third, which is very important, I would say, is role model shortage. So whenever we need to, we go for various platforms where we need to encourage women. So we need to, tell them that there are several role models today which are doing great in their disciplines, which are doing great in STEM education. So we need to promote their work. So highlighting few of them on my screen, which are largely eminent women who has contributed large to STEM education, and they are one of the role models which can inspire generations coming up. So with all of this, science outreach and volunteering is very important. So I encourage each one of you to promote, women in STEM and women in sensors. So now briefly touching upon women in STEM scholarship and grants globally, which can help each one of you to opt for various scholarships, fellowships, programs. So I'll be sharing these details with the organizers as well, which can, have more propagated knowledge over funding scholarships. So not going over each one of them, but these are some kind of international fellowships which we all can, avail by, participating in these competitions and these scholarship programs. So just touching upon these and talking that basically all these fellowships which I'm sharing on my screen are for promoting women in STEM. So yes, these can be, we can go through them, we can apply. These are for Indian. Now, these are some Indian scholarships to promote, women in STEM in India, and also some international financial assistance provided for pursuing, careers in STEM for women. So with all these, fellowships, which I'm just going through, the major ones I would like to highlight is the Department of Science and Technology has started various women scientist fellowship schemes for, promoting women in STEM and their career platform. So definitely I would encourage each one of you to share this knowledge with, young girls, with women who are availing for, financial support to pursue their careers in STEM. So that's very important. So that's what I'm saying, that we need to connect, we need to engage, and we also need to propagate this knowledge with our, peers. So that's very important, and we all can definitely contribute largely to that and help, to promote, to build, basically increase the, to close the STEM gap which is existing. So with this, I would like to thank the organizers and the funding agencies who have supported me. I would like to thank my PhD supervisors, my postdoctoral supervisors, and also my collaborators for all the, scientific contributions that we had made so far. So with this, I'm available for any discussions and questions. And thank you so much. And I really apologize for the technical issues that we had in the beginning. I hope I have made it to the time.
Thank you,
Yeah,
ma'am.
thank you.
Now the session is open for the question answer. Okay, we have one question.
Mhm.
Good evening, ma'am.
Yes, hello.
Okay. Ma'am, can you find the difference in how women are treated in India and outside the India in the field of science and research?
Okay, yeah, thank you so much for a great question. So I would say that the difference that I have felt so far is that more acceptance towards, more acceptance as well as more encouragement to women in STEM is, that's what I'm facing here. Like I'm learning here in US. So that's one thing that we need to work upon. The other thing is the opportunities for women to pursue career in STEM are increasing over time. Talking about India, talking about, global platforms. So I would say that the encouragement, the promotion for, more engagement for women in STEM is increasing nationally and internationally both. So that's a good perspective that, uh, the organizations are working on. And we all should contribute a lot in promoting being more vocal about women in STEM, because we all are contributing to this field. So definitely we all position ourselves, in this platform. So we all should promote, I would say, along with organizations. But I see that there is, change situation going on, and definitely the numbers, the STEM gap is closing, day by day, I would say. So that's good. We all should contribute to this.
Ma'am, another question. We as women find various difficulties at various stages of our life. So, what is your experience regarding this?
Yes, again, a very good question. So yes, I would say that's the reason that I shared my journey, because coming from a small state and evolving with various learnings that I have learned at during the just journey. So I would say difficulties are there, but we need to stay firm. We need to we need to stay dedicated. So that's very important. So I would say if you have a goal, you want to contribute, you have seen a goal for yourself, for your family, so then definitely you can stay firm, you can be dedicated, and you can be open to learn. So that's very important. We should work, basically what I would say when I talked about, science outreach and volunteering, we say that we talk, we, communicate science, we promote science in an open-ended world. So that's very important. So first thing is dedication. Second is motivation by your role models, which is again very important. And if you are encouraged, if you are dedicated, definitely you'll promote people around you to, support you. So that's very important. So I would say it's just like dedication towards your goals.
Ma'am, there are many intellectuals who are going abroad for higher studies or maybe for job. So don't you think that it is a brain drain of India?
Yes, again, a very good question. So similarly, taking my example, I did my PhD in India. I also, I did all my education in India, and now I'm in US for pursuing my postdoctoral research. So I would say, and another example is Dr. Shalu, who was, who shared the stage with me. So I would say, like, even if we are, pursuing higher studies or pursuing, postdoctoral research or even other studies in abroad, these all experiences, make us more global, I would say. So definitely we are here for learning. And once we are back to India, we'll be sharing this knowledge and promoting this knowledge in our country. So I would say brain drain is a good term when you, leave the country. But if you are in a, in a perspective to learn at international platform, bring that knowledge back to your country. So I would say that is more like, knowledge sharing and learning over time. So I would suggest that international exposures are very important. And definitely, if we have audience who are at doctoral and various, graduate levels, so I would encourage you all to participate in exchange programs wherein you get opportunity to work in international countries. You get to know the research facilities, you get to know about different cultures. So all these, learnings basically make you inclusive, make you diverse. So that's very important. We live in a world which is full of diverse inclusion and equity. So that's what with all these exposures we get to learn more. So that's very important. These international visits, international research opportunities enable us and definitely encourage others as well.
Okay, ma'am, that is a good perspective. Thank you so much, ma'am.
Thank you.
Hello, ma'am. Can I ask few queries?
Yes, please.
Yeah, first of all, I would like to thank you for accepting our invitation. Actually, generally, we follow your post on LinkedIn. So you frequently visit and you participate in various international conferences. So your work is generally, I think you have last participated in related to the MXC related material conferences. Actually, I have seen your post on LinkedIn. So can you little bit light upon on related to the actually as we are first we have seen the 2D TMD material. Now we are talking about amexine. So can you little bit differentiate between these two material? How we are actually entering?
Yes, thank you for your question, and I'm happy to answer it. So the first thing is, as I mentioned, that during this journey of research contributions, a very recent material that I'm working today is Maxines. So definitely rightly pointed, as a 2D material, Maxines is a competitive material to other, large family of two-dimensional materials. So comparing it with two-dimensional, transition metal dichalcogenides, so the application majorly I'm contributing to presently is energy conversion. So when we compare these two materials, I was talking about Maxines as a promising material for energy conversion for catalytic reactions. So the basically, as these both are two-dimensional materials, so both have high surface area. So that's one aspect. The second is the active basal planes. So when we talk about, two-dimensional transition metal dichalcogenides, so they have their edge sites which are active towards catalytic reactions. However, when we work with Maxines, so the beauty of Maxines is the active basal plane of these transition metals in Maxines. So they are, highly active, meaning that not the edge sites, it is the complete basal plane of Maxines which is active towards electrocatalytic reactions. So the basic, study that we highlighted in the recent conference where we presented Maxines, we talked about hydrogen evolution, reaction. So when we talk about HER performance of Maxines, so it is the surface, basically the basal plane of transition metals in which they are, designed is highly active towards HER and resulting, for their low over potential. So similarly, now we are working on a Department of Energy project in which we are using the electrocatalytic performance of Maxines towards carbon dioxide reduction and conversion to, qualitative products like methanol, ethanol. So based on this, the chemistry of Maxines and the highly active basal plane of Maxines is being utilized for the catalytic reactions. So this is the reason that Maxines are promising material as compared to other two-dimensional materials because of their high surface area and their active basal plane. However, I'm saying that the two-dimensional transition metal chalcogenides, which have their edge sites which are active towards catalytic reactions, can be tuned by further modification by either doing, hydrogenation, by doing various other materials which are decorated on these two-dimensional transition metal chalcogenides, which can improve their performance. So that's one goal. However, in Maxines, that is inherent property of the material which make them a promising material. So that is the basic, you know, regime wherein we all are working in tuning the transition metals in order to, have more lower over potentials for these catalytic reactions. So I hope I have answered the question well. And if not, then we can discuss more. I hope I'm audible. I'm open to any more questions and definitely we can interact more. So I see there's a question in chat from Swati. So definitely I'll be sharing my resources wherein I gather information on international exchange programs, and hopefully they'll be useful for your, future perspective. So I'll share these list of programs with the organizers, and definitely they can share with all the participants. Any more questions from the participants? I believe I'm audible.
Yes, definitely you are. And it was a really
Thank you.
wonderful presentation, and it was wonderful hearing you. Great.
Thank you so much.
I guess there is some internet glitch from their end.
Okay.
Yeah.
Definitely. I'll do
Yeah.
that.
Ma'am, am I audible?
Yes, you're audible.
Thank you so
Jyoti.
much, ma'am, for your wonderful talk.
Thank you.
We would like to invite which one? Miss Sidwedi for next talk. Thank you, Anupma ma'am, for your exciting and wonderful talk. And thank you so much for accepting our invitation in this short duration. Thank you so much.
Yes, thank you for the kind invitation, and it's glad to interact with everyone.
Now continue.
Hi, can you hear me, everyone?
Yeah, hello. Hello, Shivasi. I'm audible?
Yeah. Yes, you are.
Yeah, please, just wait for 3 seconds. Just wait, please.
Definitely. Yeah.
So let's continue the program. To encourage and motivate women, I would like to call Miss Swashi Dwivedi, founder of Beat Smart Tech, Indore, to share your experience regarding your startup. Welcome, Miss Swashi Dwivedi.
Yeah, thank you. Thank you so much. Um, can I share my presentation or you people will share? Yeah, thank you. Thank you so much. So, hello everyone. This is Suyashi. I'm from Indore itself, and this is something startup talk, So, I'm not here to tell you how to run $1 million company, how to run, $1 million startup, or any such things. Today, I'm here to, we all will spend time together in searching out what is identity capital, right? So we all know about the capital investment, right? Me as a businessman and businesswoman running multiple companies, the most important thing is the capital, right? So capital is monetary capital. You have multiple capitals. It is in the form of asset and liability. So all the participants who are sitting over here, though I'm really not able to see anything, I don't know from where, which end connectivity problem is there. Um, Shruti, and even I would like my presentation to run. That would be great enough, but even if it's not there, that would be as well.
Miss Tvidi, just wait for few minutes. We are sharing your slide.
Yeah, hello, Trivedi. Please wait for the
Yeah,
few seconds. We are just sharing the slides.
yeah, definitely. There's no issue. Yeah, I can wait.
Thank you so much.
Yeah, thank you. So yeah, identity capital. So all these audience sitting online and offline, can you all tell me what is your identity? Just a simple question. How do you identify yourself? What is your identity? Anyone, just stand up and just let me know what is your identity. Maybe student, maybe researcher, maybe the BTech students, MTech students. Am I right?
Hello, hi Shrishi. I see myself as a person uh, in a field of research and experience and being a part of a global community when I will be a part of like IEEE.
Oh, that's amazing identity. So yeah, there might be multiple identities, right? You all have decided for yourself. Just a day back, you might be a different person, or maybe 3 to 4 years back, you were a different person. So identities keep on changing. So we born each day, we develop ourselves every day. So today, into this session, we will learn how to develop our own identity. How to identity is a capital, right? Whether it's Shruti, whether it's Abhishek, whether it's Aditi, or the audience who is sitting over here, identity personal branding can act as a monetary thing. So how we can identify ourselves, and how we can make ourselves the best version. So let's learn. So before knowing who is teaching you to build the identity capital, let's see what is my identity capital. Can you take it forward, the next slide? Yeah. So right now, this is my visible identity. A social entrepreneur, or maybe a project management specialist, founder of Free Pustakalaya. And these are the organizations which I have worked in India and as well as abroad. So this is the visible identity right now, right? So how my question is how this visible identity has how do you create this visible identity? Do you think it is important to present yourself everywhere, wherever you go, as a woman? I guess yes. Yeah, I want the slide to be just next. Yeah. So let's create our own identity capital in 20s. So why 20s? The audience. Most of the people who are sitting there in the audience, they are in their 20s, right? BTech, MTech students, or maybe the PhD ones. So we all have a visible identity. Visible identity is whatever we prepare ourselves to show on resume, or whatever we present ourselves into the market to buy job, or maybe to run a business. But what is this invisible thing which is beyond creating this visible identity? Ki I am so and so. So according to me, invisible identity is who you are, how you speak, how you present yourself, what are your moral pillars, what are your social pillars, What are your aims in life, right? Right now, Dr. Anupama, I was listening to her, and she might have, set some boundaries, some goals before being an exchange student, or maybe, selecting that research field she wanted to be. So, what was mindset? That mindset is the invisible identity. So, today I want you all to set the goals of visible identity through invisible identity capital. So that's the gist of the following. And I guess you are able to understand. I'm not here to tell you how I have run a company or how I've done so far, but that's what I want you all to understand. If you want to be into the visible case, it's very important to set your own invisible capital. Who I will be, who, how I'm gonna, what are my principles, why I'm doing this, my whys are clear, right? I want, you people to ask some questions if you're having in middle. Any questions? Yeah. Can we just further take ahead the next part and end the following? Yeah, so as I told you, identity capital, who am I? What do I do? With whom I am right now? These are not the things which define.
Sushi, am I audible? Hello? Am I audible to anyone?
Yes, sir, you are
Yes, sir,
audible.
you are audible.
Hello,
Hello?
Miss Divyashi, can you hear us? Hello, am I audible? Maybe because of some technical issue, we are unable to contact Miss Divedi.
Yeah, I'm really
Ma'am,
sorry.
can you hear us?
Yeah, right now I can hear you.
Okay, thank you, ma'am. So, actually, because of some technical issue, we are unable to hear properly you. Have you ended your slide?
Yeah, definitely. If you people have any questions, then go ahead.
Okay. Audience, is there any questions from your end? Okay. If no further questions are there, so we move to ma'am, you can continue further.
Yeah,
Now we would
feedback
like to
link.
invite, yeah, now we would like to invite Seetal. Seetal, can you hear us?
Yeah, Shruti, I can hear you. Can you hear me?
Yeah, yeah.
Yeah.
Now you can share your slide. If you don't have share a slide, then you can continue your talk.
Okay. Just let me know if you can see me or not. Can you hear me properly?
Yes, we can hear you.
Okay, fine, fine. That's pretty good. So, before introducing myself, I just want to tell you a riddle, right? So, all you have to do, please be careful. I want answers from you all. Okay. So, let me start with the riddle. A father is about to bring his son to a job interview, applying for a position in a very big company. All right. And the moment they reach to the company in the parking area, the father and son, right? They both were there. And suddenly the son's phone starts ringing. Okay. The son looks at his father, and then his father asked him to reply the phone, which was of the CEO of the company. And when he picked up the phone, there was a sound out of him which was saying that, "Good luck, son, you have got this." Now, then he cut the call, he dropped off the call. Now, the question arises is, if his father was beside him in the car only, then who was that particular person who called him being as the CEO of the company, right? And said that, "Good luck, son, you have got this." So, can any one of you answer this riddle? Any one of you?
Mother.
Yeah, you got it right. But as a part of experiment, I asked the same question around to 10 to 15 people, and there were like multiple varied answers. Let's say some was saying that maybe he has two fathers, maybe the CEO is the grandfather of that son, or maybe the name of that young boy's son. So there was this much varied answers, right? So what I got to know from this thought of like this point is like what we have in our mind is there's a subconscious build-up in our mind that most of the people at the larger companies or in the C-suite, they are men only and not only women, right? I hope you will agree to this. Just type yes if you agree this thing. When I say CEO, most of the people imagine that it may be, a man. When I say some, let's say managing director or maybe someone else, what most of the people imagine is a man only. So that's what the situation is. Even we call ourselves, that we consider inclusion and all these things, but still there's a subconscious hit in our minds about these things. Yeah, so that was like pretty good answers from your side. Now I would like to introduce myself. Hello everyone, my name is Sheetal Singh. I am BTech pass out from IIT Indore this year only, and I'm really very happy and extremely grateful to be back here for a talk, to interact with you, right? So I'll start with my journey, how I started, and then what all problems I faced being as a girl, being as a woman of the society, what all problems I faced, and how did I overcome all of these things. So, first of all, I'd like to tell you that I work in 3 startups. There is Hexanovate, which is a software marketing, digital marketing and software development company. And in 2019, I joined Hexanovate. It was the time when I was not even knowing the term startup, what it is, right? That was the time jahan pe, I just want to know, are you all comfortable with Hindi as well? Just wanted to understand.
Yes, we are
Yeah. I was saying
able to
that
understand
it
you.
was the time I was not even knowing the term entrepreneur, startup, and what it is, right? And it was not my fault because I belong to a very small village of हरियाणा जहाँ पे एक लड़की को बहुत ज्यादा चीजों का एक्सपोजर नहीं होता है. मैंने मेरी स्टडीज थी बहुत ही छोटे से स्कूल से पूरी की एंड देन how I reached to IIT, only I know this thing. I completed my coaching from a local institute. I prepared just for 9 months, and in that 9 months, I tried my level best to crack IIT. And that was the point where my journey turned around, like completely turned around. I joined Hexanovate. I was not literally knowing anything about it. The moment I joined, just after that, COVID started, right? So Hexanovate was a startup. I was working in it. I was literally zero about anything. I joined as a marketing executive. मुझे कुछ भी knowledge ना होते हुए, I was trying my level best. And at that moment, I was working from my home only. It was peak COVID. My team got to know कि no, अगर हमें startup को आगे लेके जाना है, we have to come up together. हमें एक ही place पे मिलना होगा, and then only we can work well, because आप जब एक साथ काम करते हो, then only you are able to sync up. So it was peak COVID, and I said my parents that I need to move to Pune, because that was the place where we thought that we'll start our company. My parents denied. And the reason, it was peak COVID, right? I was a girl. So it was really, really difficult for me to convince my parents to come to Pune alone in this peak COVID situations. But somehow I convinced them, and the only reason was I was somehow very passionate about my things, right? I was very passionate about Hexanovate. I literally wanted to work in that. I found, like, I literally fight a lot for that. So that's what happened with me. Like, I belong to a place jahan pe in my age girls are getting married, right? That's the situation of India. Like, not only my place, I can see the same situation across all India, right? आपके भी बहुत लोगों के घर में बहुत सारी problems होंगे. I can really understand. Being a girl, I can relate to everything. Marriage pressure होता है, and then people don't really value much. ये बोलते हैं कि क्या करेगी पढ़ के, क्या ही करना है इसको, आगे जाके तो शादी करनी है. There is no sense of giving them this much exposure. अकेले से बाहर की सिटी में जाएगी तो कैसे मैनेज करेगी. All these things, all the taboos I was having in my head, and my parents was pressuring me for the same thing, that you can't go because सोसाइटी क्या बोलेगी, लोग क्या बोलेंगे, हम उनको क्या जवाब देंगे. ऐसे मरती हुई सिचुएशन में, इन दिस पीक कोविड सिचुएशन वेयर शी इज गोइंग फॉर वर्क, राइट? आप पैसे के लिए, काम के लिए, उसके सपनों के लिए आप उसको उधर भेज रहे हो. डजंट मेक एनी सेंस. सो इतनी सारी चीजों के बाद आई समहाउ कन्विंस देम, बिकॉज आई रियली वांटेड टू वर्क इन हेक्सानोवेट. इधर आने के बाद अगेन देयर वर अ लॉट ऑफ प्रॉब्लम्स, रहने का, मैनेज करने का. एंड इतना ही नहीं, when you work with the team, I was having 6 to 7 people in my team, and all of they were facing the same problems. Like, I can't tell you the situations, like the problems you face being a girl, right? So I literally faced a lot. So मुझे मालूम है girls के साथ कितनी सारी problems आती हैं. I really do understand well. But all you have to do is you have to be very, very dedicated about your goal. You have to be very, very oriented. You have to be very focused. And ये सारी चीजें आपके पास तब आएंगी when you will get more exposure around yourself. जब आपको सारी चीजें पता लगेंगी, when you will get more visibility, right? So जितना possible हो, I really wanted to tell you one thing only. जितना possible हो आपकी life में, you must have goals, and you try your level best to achieve them. With this dedication, I came to Pune. I was doing good in company, and that's when we started thinking to come up with 2 more startups. One is IIT and Guidance, and one is Tapri IIT and Ski. So just wanted to know how many of you have visited Tapri IIT and Ski Cafe at IIT Indore? How many of you visited it?
Yes, ma'am.
Have you visited? Yeah, so you can say I'm the founder of Tapri IIT and Ski. All right. So once we were settled with the one business, like we started to solve
Yes,
some more
ma'am.
problems. Like when I was in my second year, I faced a lot of problems. I was not having exposure. I was not knowing about a lot of things. मुझे क्या करना चाहिए मेरी लाइफ में, कैसे करना चाहिए, किसका सपोर्ट मैं लूँ, किसका नहीं लूँ, बिकॉज मेरे पेरेंट्स को उतनी नॉलेज नहीं है कि मैं उनको बता सकूँ एंड देन दे कैन सपोर्ट मी. सो ऑल आई वाज हैविंग इज माय फ्रेंड्स, टू बी ऑनेस्ट, राइट? एंड दैट्स व्हेन I come up with them, and working in this company, I really got to know there are problems with the people while they are even graduating. They are pursuing their graduation. They don't even know what do they actually need to do in their life. So that's when we realized to come up with something that we can tell, we can promote some thoughtful discussions, we can actually tell them that what you can do in your life, right? क्योंकि जब आपको 100 चीजों के बारे में मालूम होता है, that's when you can pick 2 or 3 for yourself. So by Tapri IITians, what we are trying to do is we are trying to spread awareness among people for the multiple options they have in their lives. That's what we are trying to do. Now, let's get back to the women thing. I really want to focus on that. So what currently I'm focusing on, when you have a goal to pursue, everything vanish. It goes away. आप अपने पेरेंट्स को कन्विंस कर लोगे, you have to convince society a lot, you have to tell them that you want to work on it and don't listen to anything else. That's all what I want to share with you. And to uh, make this, to bring out something out of this, in Hexanovit particularly, I lead the content department, and what I'm doing is I am looking out for girls only in my department, in my team, to work with me so that I can help at least 10 to 15 girls. I can help them. I can tell them that your dreams matters a lot, right? You need to step up. You need to take out of your comfort zone. You need to fight for your dreams. You need to, fight fight with your parents as well. So that's all I wanted to share with you कि कुछ भी problems आए, I really I can understand what all problems you can face being as a girl, but if you have a goal, if you have a dream to achieve, just crush it anyhow I'm saying. Yeah, so that's all I have from my side. So if you have any questions, you can ask me. Do you have any questions?
Thank you, Sheetal. Am I audible?
Yeah, you are audible.
Any questions from audience? Okay, there are no questions. Thank you, Sheetal,
Yeah.
for sharing your experience.
Thank you so much. Thank you so much for inviting me.
Now it's time to reveal the winners. The winner of poster presentation is the best model presentation goes to Tanmay, Pranesh, Yash, and Pratyaksh. The winner of quiz contest is Ramya Eshwaran. And last, the winner for poster presentation is Miss Bhavna Saini. After a great and a motivating session, I would like to invite Ms. Kumari Jyoti for a vote of thanks. Thank you.
Thank you, Minu. Thank you everyone to join this session. Today, IEEE Sensor Council Student Branch Chapter at IIT Indore has organized Empowering Women in Sensor Technology with an objective to create an interactive platform for the students, especially female members, to discuss and collaborate with academicians, research scientists, and industry professionals working in the field of sensors. I'd like to thank our chief guest, Professor Chachi Hanikar from IIT Jodhpur for addressing the audience, but because of some personal issues, he unable to attend. I sincerely thank Dr. Sanjeev Singh, Associate Dean of Student Affairs at Indore, for his administrative support. This event has become successful under guidance of Mr. Pawan Kumar, Chair of IEEE Sensor Council Student Branch Chapter. Thank you, sir, for your kind support. I'd like to thank our eminent speaker, Professor Sudeshna Chattopadhyay and Dr. Nitya Tiwari, for accepting our invitation and delivering very informative technical talk based on sensor in technology. Also, I'd like to thank Professor Sravani Mathur from Oriental Institute of Science and Technology for enlightening us about importance of different sensor in today's life. Thank you, Dr. Tanvi from Solvay Research Center for your view on thin film battery technology. We are grateful to Dr. Priyanka, Senior Scientist at AV Consultancy, for giving us insight into emerging photovoltaics technology, and Ms. Suchitra for rightly address the empowerment of women in various sectors. My sincere gratitude to Dr. Salu for her exciting talk on flexible supercapacitors. I deeply appreciate Dr. Anupama for her educational journey and her talk on nanomaterial for smart sensors. In today's world, everyone is curious about the startup. In this regard, I thank Ms. Divedi for sharing her journey of Beat Smart Tech. Also, I'd like to thank Ms. Sheetal for sharing view on how to implement the startup idea. This talk surely served our purpose to empower women in sensor and other technology fields. I'd like to thank Mr. Vivek from Kendra Vidyalaya IIT Indore, coordinating from the model presentation. Thank you all students and participants of poster presentation, model presentation, and quiz contest from your performance and responses. Our sincere gratitude to all the attendees, especially from GDPR, for their kind attention and presence in the event. I thank all teaching and non-teaching staff for their help and cooperation for making EWST event successful. I'm also humbly thankful to all the professors and their team for running various IEEE chapter and branch and organizing such events which contribute to encourage the research in various fields in India. My special gratitude toward Professor Saival Mukherjee sir for his eminent guide and support to make this event successful. Last but not least, it's my privilege to congratulate all organizing team of EWST 2022 and all member of IEEE Sensor Council Student Branch Chapter taking up initiative to present IIT Indore in such vibrant IEEE platform. Thank you so much, you all. Thank you.
Thank you all the participants for joining the event. Now we are closing the event.